it shouldn't go too much longer.
What's up, guys? Woo! We had a lot of thunderstorms yesterday. Nothing but thunder. My God, it was a lot. I think it was either one system or 2 or 3 systems. Why? Yeah, it was fucking crazy. The power went out for like 20 minutes. Shit was fucking insane. I did a really badass meditation though. Woo, that was great meditation. I felt amazing. Amazing. Yeah, it was fucking crazy. I probably want to buy better meditations. Got my little C4 here. Ooh. I leftover pizza.
Touche. There you go. It's one. You're good.
Alrighty. Can we see this? Is this
Yes.
seen?
Yep.
Okay. Alright, so I wrote this, so I'll just sort of paraphrase through it. The question is, with the inverse square law, how are we able to see the North Star? Okay, Polaris. So the way that we kind of understand it, we have a point source of light, like a star, and you can imagine that light emanating off of it, you know, in sort of circles, like spheres coming off of it. So we're interested in the intensity of light at any distance from the center. And so we would have to know the surface area, the area of these spheres, of any one of these spheres, like however distance you want to know, which is going to be given by the radius. So in this case, the center's there, radius is the distance, and the surface area is the area around the sphere. So this is basic formula, like first grade math kind of stuff. So the inverse square law is basically this.
I think first grade is a bit. I mean, I definitely didn't learn. I definitely didn't learn this in first grade. I'll just say that.
Well, I just meant like formulas for like basic formulas. You know, like volume, area, perimeter, surface area is one of those. Is what I meant. So 4 pi r squared. And so, all right. So this is kind of what's happening. So imagine these are the different spheres here, right? And so, like you were saying, Dave, the further away you get, so at 1 r, one distance away, you have a certain intensity. Then you go 2 times as far away, you have a quarter of the intensity. And then 3 times as far away, you have a ninth, and so on and so forth. It's kind of, you know, it's just a simple. And then this graph here kind of displays that relationship. You've got distance on this x-axis here, and then the intensity here. So you can see 2 times as far away, a quarter, 3 times, 4 times, and so on and so forth. So it gets dimmer, obviously, the further away that you get away. The big important part here to realize is that the further away you get, the less difference there is in brightness. So yes, it gets dimmer, but the amount that it gets dimmer is a lot less the further away you get. So the example I gave here, say you're like 10 times as far away, you'd see 100th of the brightness, or 0.01. Whereas if you're only 9 times as far away, you'd see 181st, or like 0.0123, which is only a difference of 0.0023. It's not that much of a difference if you're 9 times as far away or 10 times as far away. And the further away you get, again, like the less difference there's going to be between those brightnesses. Okay, so that's the big point here.
At what distance do we start to really notice that relationship?
Well, that's what I'm saying. That the more distance there is, the less you're going to notice that relationship. So, David, you're muted again. Sorry.
Thank you. That's 2. I'll do it one more time. So you're saying that, you know, something is a ridiculous distance like 100 light years. Long before you get to that 100 light years, you're saying that the difference between like 20 light years and 50 light years isn't very much. It isn't as big of a difference as the first few steps. Is that what you're saying?
Exactly.
Okay.
That's correct.
So something's 100 light years away, then can you see it at 200 light years? Or it remains the same intensity at 200 and 300 and 400 light years? It goes to a point where it stops getting less? Is that what you're saying?
Well, sort of, yeah. So well, there's not going to be a point where it stops getting less, but because eventually, you know, obviously it's going to be past what you can see. It'll be too dim. So, but there's also nothing obstructing the light from getting to our eyes. Like, for example, in some of the stars in the core of the Milky Way here. Oh, this way. Yeah, so a lot of these stars here, you know, they kind of just look like a haze at this point because they're really far. You can't see individual stars with your eyes, but you just sort of see this haze. So the light's still getting there, but you can't make out the stars themselves, the pinpricks, if you will.
Well, the only problem with that, just to interject for a moment, is that normally when you have something that's too far away to see that it's like pinpoint, right? When you zoom in on it, you're not going to be able to make it bigger, right? At least not with, not unless you have an intense, like a ridiculously intense amount of zoom, right? Most of the time, you would agree that you're with like a camera, right? You're not going to be able to zoom in on something that's, you know, 400 light years away. You know, we're seeing a pinpoint source, right? Would you agree with that? That we're not going to be able to zoom in on that?
To a degree, yeah. Essentially, you can't get a whole bunch of detail out of something unless you're closer to it. You know, if you're really far away from something, you can only zoom in so much. So yeah, I agree with that.
Well, it's actually it's not just that, but also the actual size of what we're talking about. So there's a point where you're pretty much only seeing a point source of light, and then there's almost no difference between 200 and 400 light years. So basically, the claim that you just made in simplest terms, right? So if that's the case, then when you have a star that's 400 light years away, you're seeing the pinpoint source. Zooming in on it a little bit is not going to bring that size back in, right? It's not going to get larger by zooming in on something that's okay.
Yeah, that's relatively accurate. Yeah.
Okay. So the problem is that we have tons of videos of people zooming in on stars, and they get bigger every time. So, and that's what P900s.
That's a slightly separate subject. Let's go ahead and just finish this off, because the second part of this, I explained the concept, and now I plug the numbers in. Is essentially what's happening here. And then once we get through this, then we can have the discussion. All right, so I said let's plug everything in. So there's a couple terms here. So what we are looking at here, when we're looking at like the area, this is like square meters, right? You have a meter here and a meter here, so it's square meters. That's actually going to be called the flux. So that's an astronomy term for it. And then luminosity is whatever the star's wattage is, output. So it's the same thing. The inverse square law is the same thing. We have luminosity here, and we're trying to get the flux. That's basically like if Earth was right here, you want to know how much light is sort of like at this sphere, at that distance away from the star. So that's the flux. So all we need to find is how bright the star is and how far away it is. So its estimated Polaris is 25,000 times brighter and 50 times larger than our sun. All right, these are estimates, but we know the luminosity of the sun is this. So I call it L Sol. So all you have to do is times that by 2,500 because it's 2,500 brighter. So we multiply that out, we get our luminosity. So this is the supposed wattage output of Polaris. So we have our L. And then here, it's 431 light years I put here. You could say 433. It's going to be kind of negligible at this point.
Would you agree that this is all theoretical?
No, I wouldn't. A lot of these are hard numbers. So
which one would you say is the hard number?
Well, certainly the luminosity of the sun.
How did we get the luminosity of the sun?
You can measure it with spectrometers and with light measurements, essentially. Like you can measure how much light is hitting a sensor.
Okay, that's
Joel,
fair.
do you have any examples of anything that's twice as bright as the sun?
I mean, there's plenty of stars. Like stars.
No. When you look at a star, you can theorize that it's whatever number brighter than the sun. But do you have any examples around here of something brighter than the sun? Twice as bright.
The issue with that is the sun is giving off all wavelengths on the electromagnetic spectrum. So I could find something that's brighter in the visible spectrum, but not like on all wavelengths.
I find it hard to imagine something twice as bright as the sun. But let's just go 10 times as bright as the sun. 10 times as bright as the sun.
I don't think there's anything brighter than. I don't think there's anything even visibly brighter on the visible spectrum. Brighter than.
But let's just say 10 times. Let's just pretend that we can do something 10 times brighter, which is unfathomable to me. And you just carefully, because you're doing some equations. Equations are not empirical evidence. Saying this star is 25,000 times brighter than the sun, and you just roll it off like it's a fact, but you have zero evidence of that other than it has to be if you pre-assume space is real and stars are far.
Well, I also wanted to get...
Not necessarily, because there's neutron stars and there's very dim stars as well.
But I wanted a clarification on it. Are we talking about the sun's apparent brightness, like its visual brightness to us, or are we talking about its actual light
its
wave?
Actual brightness.
Okay, so how did we get that compared to its brightness to us?
We sent probes into it. So I know you don't believe that, but that's how we got that data. That's why it's.
Do you have any evidence of those probes going to the sun?
Yeah, you can look it up. I don't know what their names were.
So you can look it up, and it's written by NASA. I believe last time.
I think that was actually a Russian probe. Was the one that went to the sun.
Not Russian, China, Japan, NASA.
You gotta.
We don't have to believe the story about Narnia.
No, you don't. That's what I'm saying. Like I could say these things happen, but it's kind of hard because I know you guys don't believe it, but that's like what am I supposed to fall back on? I guess.
But that's kind of where our problem is that we're looking for what we can actually verify, and we're always having to rely on these stories from the accused, right? And so it's just not. I mean, it's really not very good optics for the globe model.
All right. Well, let's just continue. So we got to find the distance now, right? So we only have 431 light years, but our flux measurement is supposed to be in watts per square meter. Okay, so we can't use light years. So I converted light years to meters, and then 401 light years is this many times that many meters, which are how many years one is in 1 light year. And so we get the amount of meters. This is how many meters away Polaris is. So now all we do is we plug that in. We get the luminosity of Polaris, and then we get the distance. All I did was plug those in. This is the luminosity and the distance, squared the distance, multiplied it by 4 pi, and then I divided them. And I got this really tiny number, right? So 4.61 times 10 to the negative 9th watts per meter squared, which is really small. That's this many zeros. The sun, for example, is 1,400 watts per square meter. So that's in the positives, not in the positive. That's past the decimal point. That's 1,400 watts per square meter. This is 0.00000, like really, really small. And so for a comparison, and by the way, the human eye, the lower limit is in the magnitude of 10 to the negative 10. So anything below 10 to the negative 10, our human eye wouldn't be able to pick up. And then another reference is one foot away from your average candle, which is how we get luminosity measurements as a standard. That's going to be 0.01576 watts per meter squared. So it's still pretty small. It's a small, it's a relatively faint light. So then I looked at all of these other stars. So we have Sirius, which is the brightest star in the sky. It's only 9 light years away. And that's still 10 to the negative 8th. And you can see that sort of relationship here of how they're not that different. It's because we have 10 to the negative 8th, negative 8th, negative 8th, and negative 9th. With all these different, Rigel, I never know how to say that, 773 light years away, and that's still negative 8, while Sirius is only 9, and it's still like negative 8. So you have a bunch of different variables in size and intensities. But you have Polaris at 431, and it's only at negative 9, and that's above our limit of being able to see the star. So with all the numbers, with the distance, and with the size, we would be able to see Polaris with the inverse square law. And that's essentially kind of how the numbers would work out. We could now have discussion about the sources of that stuff and all of that good stuff, but with the numbers that we purport to have now, it does work out. If it's not against it.
So I'll throw something in, and then Scarlett, you can go. Everything that you're telling us you're great at math, by the way. You're awesome, and great charts and everything. And I could actually show you a chart of an unknown island off of Japan, one of the 7,000 that they just found. And there's an amusement park there with the biggest roller coaster in the world. And I could show you the coordinates for that. I could show you how far it is. I could tell you the specs on the roller coaster, the G-forces. I could show you all of the building plans, everything all about it. And everything will add up no matter how you look at it, sideways, forward, reading it, upside down and backwards. Does that make that amusement park on that island real? Or is it just theoretical? Right? So everything you're talking about is theoretical. You're pre-assuming that space is, infinite and expanding. You're pre-assuming that those lights in the sky are billions of miles away and 25,000 times brighter than the sun, to me, which is absolutely insane.
2,500.
2,500. Well, if it was twice as bright, that's still insane to me. And so this is just a quick quote. All of the theoretical work that has been done since the 1970s has not produced a single successful prediction, says Neil Turk, director of the Perimeter Institute of Theoretical Physics in Waterloo, Canada. That's pretty intense.
Well, what about all the theoretical work done before the 70s?
Like what?
Like general relativity?
I'm not a fan.
That's the big one.
Not a fan.
Yeah, so actually there's a big discussion on upending general relativity amongst even mainstream physicists. It's actually, when you look at that coupled with Big Bang Theory and what they've been teaching in the mainstream schools, there's actually 16 predictions that the theory gets completely wrong. And the James Webb Telescope has actually only apparently furthered the mystery. I know for us it's like a catch-22. We don't believe in the James Webb Telescope, right? So why are they, spinning these different narratives? I think it's for confusion. But in any case, even if the data is real, right, the data is not lining up for the expectations of general relativity. But again, that's kind of a different topic than the discussion of the stars. when we
My
get
main point was just because a majority of the last interview was saying how the inverse square we shouldn't be able to see Polaris, and so at least with the numbers that we have, we would be able to.
So I mean, theoretical numbers. You're making a statement that
Well, they're observations.
hold on. You're
numbers.
not making an observation. You're making a statement.
I'm making
Hold on. That light, the light of a star will get dimmer and dimmer fast, and then it gets less dim and less dim, and then it just travels forever and stays at the same brightness. You have no evidence of that being real, and logically it doesn't make any sense to me. But you have no way to prove that that's real. It's just a theoretical statement that has to exist for your infinite solar system, infinite galaxy, and universe to exist.
I'm not sure that they're infinite. I'm not sure I believe it's infinite.
Well, expanding, very large, bigger than the flat Earth concept, if you will.
Sure, yeah, it's definitely bigger than that.
Right. So you're reaching to places that you can't verify. You can just read books and trust government agencies. They're very trustful entities, and you're not looking here on Earth where we can actually scientifically prove that we're not a globe. I mean, you want to believe that Polaris is 2,500 times brighter than the sun, which that's crazy. I mean, if that was the case, there's other stars that are probably 100,000 times brighter than the sun, or a million times brighter, right?
Not a million. I don't think a million.
Okay, yeah, but
many magnitudes, yeah.
But these numbers that you're coming up with, but they all kind of look pretty much the same. And when we zoom in on them, they all
that's proof of the inverse square law to me. I think that's proof of the inverse square law that the further away
they all
things
look the
get,
same. Everything just evens out.
Well, in our local celestial neighborhood, yes, but like once you get further out, like out to the middle of the galaxy and stuff, things look a little different. They get denser and they get closer together, and they get into you have nebulae and everything like that. So, and then you have other galaxies, and then you can zoom into and see specific stars in other galaxies.
Do you believe in the James Webb Telescope?
Well, yeah.
Okay, so the James Webb Telescope, it finds a spot called Lagrange Point 2,
yeah.
And that's where the gravity of the sun and moon and the Earth, and it just finds that perfect spot. Okay,
yeah, the saddle point. Yeah.
Yeah. So over the course of 6 months, the sun and the distance between the Earth and the sun change. I had all the numbers before, but
Yeah.
as it changes, it would have to move like it's in a tractor beam. Okay, it would have to move, and it's moving like very fast in two different directions. Throughout the year, towards the sun and away from the sun, and you're just believing that tractor gravity is holding it in the perfect spot. Here's my question, though. If you watch the launch, did you watch the launch of the James Webb?
Yeah, I did.
And it was over Earth. Maybe that's not it. That's me making a James Webb image. Let me just find something here for a second.
You good?
Where is it? Here it is. I think this is it. So this is the launch. Let me just see if this is the video I want. And it's up in space. And then is it deploying here? All right. So it's the next one. This is it. So here it is, and they're showing us this beautiful curve of Earth. They always show us this beautiful curve of Earth. So it's ejected it here. Now, how many miles away from Earth is that? Is it 1,000,000 miles away? It's not 1,000,000 miles away. It's a couple hundred miles away.
Yeah.
Right?
Yeah.
Let's round up to 1,000. Let's say it's 1,000 miles away. Got a great shot of Earth. Somehow we can see through all the atmosphere and see the perfect edge of this. And here it goes out here, and it's going to deploy. Let me just jump forward. It's gonna and if you watch, the signal's breaking up here, and it's only 1,000 miles away, probably a lot less. And it's going away. It's already ejected from the rocket.
Yeah.
And I'm going forward, and it's out. It's now putting out its solar panel.
Right.
How does it go park itself 1,000,000 miles away? What gets it to the Lagrange point?
Well, that's literally rocket science, man. I mean, that's orbital mechanics. They exceeded the escape velocity of the orbit, and so it was no longer within the.
So you're saying the rocket is in orbit, and it pops the satellite out, and then that satellite knows to go 1,000,000 miles away and park itself. Is that what you're saying?
No, not necessarily. It doesn't know to do. It's.
How does it get there? How does it get there?
I think you need to know that it's constantly correcting itself.
How does it correcting? Does it have engines on it?
No, it's got. I don't know, the nozzles, pressure nozzles. I don't know what they're called.
So the satellite has pressure nozzles that are pushing against what? What are they pushing against?
You don't have to. It's not the pushing against. It's the fact that it's pushing something of itself out. So it's equal and opposite.
And what is it
reaction.
pushing out? What is it pushing out?
Pressure, air pressure.
Gas. It's pushing air out.
Gas.
So,
Yeah.
so have you ever seen where we take a vacuum chamber and we put a little rocket and a fan and all sorts of stuff and nothing moves? We just light it and it it won't. There's no propulsion. There's no pull. There's no push. We hang a feather in front of a fan and there's nothing. There's nothing. So we can argue that all day. It doesn't matter.
Yeah.
You're saying that this thing with little, where are the thrusters on here? If you take a look at it,
I think I can actually see them right there. There's one at every corner. At every corner.
So those four are going to take it out of orbit and park it 1,000,000 miles away. That is a faith. That is a religion.
I have another big question, big one for
I think it's just math,
right? Well, I'd like to see you try to use math to get out of this one. So we know that there's something called back pressure. That's how all our pressurized systems work when we're dealing with gases with pumps, right? So we have atmospheric pressure pushing down. Without that, the gas will escape the pumps, right? So out in space, there is no back pressure. So what keeps the gas from escaping?
Gas from what?
The thrusters.
Well, they're nozzles. They open and close.
Yeah, but see, okay,
it's like it's a container. They're contained inside of the thing, and it pushes it out. And it's like if you were to blow in space, I guess. It doesn't mean it's just going to deflate immediately.
Can I ask what right here? They're having this bad video feed. Is it going to get better as they get farther away from Earth? Are they going to be able to transmit some high-res pictures because they can't seem to transmit a picture here?
Well, I don't think the craft, the rocket, followed it. So, I'm not sure what you mean.
So the transmitter on the telescope is better than the one that's on the rocket. Is that what you're saying?
Yeah.
I'll go with that. Yeah.
Yeah. Well, I think we could go ahead and move to the next thing I wanted to talk about, unless you guys had something.
No, we'll go to the next thing. Skylar?
I still had one thing on the stars too, because my point on the fact that we can zoom in on all the stars and they all increase in visual size in the camera lens is evidence that they can't be at these varying distances of vast light years away.
So I'm not sure what footage you're talking about.
Amateur footage.
That's not just blurry.
There's hundreds.
Besides blurry,
but you can just call it. I mean, I understand that you can just call it blurry, but even the blur, right? It's getting bigger in size. Like that wouldn't happen. It's a point source.
So I'd encourage you to take a similar camera, or to ask someone to do this. Take whatever camera that you did that with a star, and do it with like a different type of smaller dim light. Put it off in the distance in a dark area, and zoom into it, and it's going to look the same. Because it's a blurred. It's just so exactly how you described earlier. Remember how you were just.
Well, when you do it here on Earth, the diameter of it is, or not the diameter, but the actual angular size of it is going to increase, right? Of the actual thing.
No, it's going to get blurry, like he's showing that. That's blurry.
That's blurry. It's pretty sharp to me.
No, that's what happens when you sort of when your camera zooms in too much, that it's not able to actually process the light appropriately. So all it's getting is just a bunch of random protons. That
you can see this with your naked eye. You don't even need to zoom in to see Arcturus. You look at it on a clear night, and you can see this with your naked eye.
Well, yes, it sparkles. It twinkles because of the atmospheric distortion in the way.
The atmospheric distortion.
Another interesting an interesting way you can tell that, and I encourage people to try this as well. Look at Arcturus or Sirius or any other bright star when it's lower in the horizon, when it's near the ground, and then look at it again when it's straight overhead, and you'll notice a big difference in the distortion there, in the twinkle.
Well, absolutely. You're looking through the atmosphere; everything's distorted. Look at somebody, a quarter of a mile down the beach, and they're going to be all distorted.
Yeah.
But you look at something over your head, you're looking through less atmosphere. So just because you can distort things by looking across the thickest part of the air column doesn't
I love these
doesn't
guys.
mean that doesn't mean anything actually. But why doesn't this one look like Sirius? Look like Arcturus? This is Sirius. Why doesn't Sirius look like Arcturus? Why does every star have its own personality, focused or not?
That's a really good question. But that kind of gets a little bit into spectroscopy because they all have different chemical makings. Obviously, it also depends on the atmospheric conditions of the day, the camera you're using, So I mean, obviously, so that top middle one, for example, is very clearly out of focus.
Absolutely, 100% agree. Let me ask you a question. They tell us, we're looking at the star, we're looking up through all the layers of our atmosphere and all of the radiation belts and everything else, but we can tell what gas the star is made out of. How come they have never done an experiment here on Earth, like get a garbage can, fill it with whatever gas you want, put it a quarter of a mile down the street, and then get somebody with a spectroscopy, the spectroscopy instrument, spectrometer, thank you, and have them tell you what gas is coming out of the can. No one's ever done that.
That's okay. I think that's just because. So what spectroscopy is measuring is actually the wavelengths of light, and the different types of wavelengths of light will indicate different sort of gas.
So I have a challenge where we get a garbage can with a big bright light in the bottom of it. We fill it with a gas, and then we have somebody with a camera, let's say a mile down the road, half a mile. And now they have to tell me what gas it is. I'll point the light towards them, I'll pull the top off, and let the gas escape with the light behind it. And you think that somebody can do that. It's never been done. Right? They haven't tested these instruments here on Earth, and they just shoot them in space and go, oh yeah, well that's hydrogen, oxygen, and we can tell what it is. It's all, again, theoretical nonsense.
Well, the trash example is just that's not exactly what's happening. So
what you're saying is you can see the light and the gases in front of the light. I'm giving you a light with gases in front of the light. It doesn't have to be a garbage can. It can be a beaker. It can be whatever you want. We can put the gas in a beaker and put a light behind it. And you think you can tell me what gas is in that beaker?
So
I say you can't.
The thing is, it's heated. It's actual gas fusion. This is an actual active chemical reaction that's happening. That's the thing that's giving off the light. It's not just like a light with gas around it.
Where else do we see that? And where do we see that?
Xavier will try to explain space. They can never explain it. Man, where's my big old dildo at? I mean, how did I put that damn thing in? Right in front of me, big and blue. Keeps me straight up. My chair sinks in too much, and it causes my ass to sweat.
Terrestrially, to be able to make that comparison.
Well, it's only with stars. Those are the only stable fusion reactions. Unless you want to blow up an atomic bomb, that's the one time that we have that fusion.
Let's pretend stars are real and that they're spewing out gases, and then we make a device here on Earth. We can look at it and tell you what it is. How did they adjust it? How did they set it so they can know that it's right? What proof do they have that they're right? What evidence is there that any of it is right?
Sorry, Dave. That was just a very general question. I'm not sure I got it.
When they take their instruments here, the spectroscopy. What's the word?
It's okay. Just spectroscopy.
No. The instrument itself.
Spectrometer.
Okay. So they're taking that. They're looking at a star in the sky that's burning off gas, or whatever, and they can tell what it is. How did they calibrate it? If they never did it here on Earth, they're looking up at theoretical planets and stars, and they're telling you what gases are there. It is all complete and total theoretical science. None of it has been proven.
Not astronomically, we haven't done it astronomically, but we know what types of light and chemicals give certain we know the characteristics of certain chemicals, and how they fall on a spectrum. How they fall on the spectrum, right? So you'd be able to see the spikes in which chemical is what, and that's with most things. You can test that terrestrial. But then when we point it up at a star, and we're sort of receiving the information from that star, light, electromagnetic information, you can see where the peaks are. And
what about all the gases in between that are here in our own atmosphere? It ignores those.
Well, I mean, that's why we have observatories that are actually outside of the Earth's atmosphere, things like that.
Like the self-driving parking. James Webb Telescope.
Well, again, it's not completely self either. I mean, you're able to calculate almost exactly, essentially, of where it's going to go and how fast and all of that. So it's very...
So you have no idea how it works. You just say somebody knows. The guy knows what lab code low tide knows.
Oh yeah, I don't know everything, but I know how orbital mechanics work and how things can sort of fall into orbit, fall out of orbit.
Theoretically.
Well, yeah, but I mean, I gotta be honest with it. It's just slapping theoretical onto everything. Well,
we don't slap theoretical on things. We have things that are here on Earth that we're trying to measure that are not theoretical. But go ahead, Scott.
I was going to say, if you're going to say that, I mean, that's kind of a cop-out. We can define what's theoretical and what's, actually verifiable, right? So when we're saying, when you say the hard number is the sun brightness before, right? The thing that made it the hard number was the growth, right? So we had to rely on the storage of uranium. In this case,
that's not the only thing. But that was just one example. But one of the many ways
I'm not trying to start a whole other rabbit hole on the sun brightness, so we already moved on. In any case, spectroscopy. When we're dealing with a spectrometer, right, there's obviously a big difference between pointing something up at the sky and looking at a light in the sky, right, versus actually having an enclosed environment, lab, and because most of the time when we're doing, from the experts in the field of spectroscopy is done in an enclosed environment. The spectrometer is all enclosed with known variables, so everything's known when they're analyzing, when they're attempting to analyze these chemicals. So, again, we're only between millions, billions of miles, trillions of miles, but unfathomable distances. We're invoking consistent, unchanging mediums when we have no way to verify that whatsoever.
Well, the verifying is those observations. That is the verification, I guess. So, I mean, I know you guys deny it, but that's the verification. Is you can take the same sorts of instruments and measure the same types of things, and you get those observations, then we get these numbers that we work off of.
So Aristophanes, with his sticks and shadows, he measured the second shadow. Hold on a second. And he said, all right, the Earth's diameter is so-and-so. And then later, somebody said, the Earth's diameter is so-and-so, and if we took a stick and a shadow and we put them 5,000 miles or 500 miles apart, those measurements would actually equal the Earth. So you're self-reifying your space with space. You're using space as your proof of space when there's no proof of space.
It's also interesting how confident you are in spectroscopy when, the people at the top actually aren't that confident. They're like, yeah, there's tons of problems, there's tons of things that we're trying to weed out, and a lot of times we do end up with unexplained phenomena. So, again, you're just kind of relying on the authorities, right? Because, I'm just like you. We were spoon-fed one model. But when you actually talk to the people who are doing the work, people like George Ellis, they admit that there's a range of models that can explain the observations, but cosmology is choosing them based on philosophical grounds.
Yeah, there was a lot there, but we're both sort of appealing to some sort of authority at some point. So,
well, let's stop doing that. Do you have was there a third topic you want to bring up, or can we discuss something else?
I've only got through one so far.
Okay, all right. I thought there was two. Go ahead.
Yeah, so the next one,
then maybe we can interject after that one.
The next one was this video that I got.
I do want to shout out Karen B with the super sticker. Appreciate the shout out and the support. It does help out the channel a ton. Be sure to, if you guys enjoy this kind of content, then definitely check out the GoFundMe. We're trying to make it to Flattoberfest. There's only one way to find out if I'm an AI or not, and that's to get me to Flattoberfest, where you have a chance to shake my hand.
That is true. Joel, I don't know if Skylar's real. He could be AI. We're trying to get him to Flattoberfest. You should come to, where do you October?
Oh, I'm in Ohio, so it's not
Okay.
far. If I was closer,
All right.
maybe. Okay, so let's go ahead and move on to this. I thought this was interesting for you guys to look at. So I'm sure you've seen stuff like this, but I guess the interesting thing of note is the direction that this was taken.
Okay.
So in April, I went to Australia to meet with my fiance, and we went to Kangaroo Island, and this was looking directly south. So I'm curious what sort of explanation that you guys might have for this sort of observation. Because obviously, like on the flat Earth, so this is kind of where I was looking out. That's the way that the angle was with the camera, and we see these stars rotating in a clockwise direction around, I think the rotation point's somewhere around here, right around in there. So that's technically, for me, that would be the celestial South Pole. So if you were to, on a globe, to extend the South Pole out and sort of...
Is the Southern Cross in that picture?
Yes, it is. Yeah, it's right there.
Okay.
Yeah. So
Charlie,
the
you want
Southern Cross is going around this way.
Yeah, so when you're dealing with the star rotations, first off, just for data's sake, right, did you happen to have like a compass or any way to verify the direction that you were facing?
Yeah, I had a compass. Yeah.
Okay,
Yeah,
awesome.
because we had to use the maps to drive there and we had to navigate there and everything. So, and we just looked out into the. I mean, if I zoomed into this map, this flat Earth map here, I would be standing on this edge of the island, looking this way. So, yeah.
Sure. I mean, the thing is, when it comes to the stars, there's multiple explanations that we can try to explain what's going on there. None of them in any way actually prove the shape of the Earth one way or the other. That's why, as Dave's famous for quoting, shape of the lights in the sky don't indicate the shape of the floor unless you beg the hell out of the question, as the globe does tend to do. So with the observation, I've actually been challenged with 3 points, right? You have somebody on each continent at the same time looking out apparently south, right? So there's a couple of issues. For one, I do understand that you have a map that you can use to navigate locally. However, when it comes to the larger scale, there's also something called magnetic declination. When we actually tried to navigate using a globe back in the 1800s, we were wrong consistently. So we went back and we made all these corrections. And I say we, the British military did. So went out and made all these corrections, and now we have our ever fluctuating magnetic declination map that's almost impossible to predict more than a few years out. What predictions we do have are iffy at best, but we're still going to invoke that maybe we'll have a shift in a couple thousand years. This is actually going to determine how we navigate. However, the stars themselves are not going to be oriented based on the magnetic field, right? So how do we actually verify the direction that you're facing, literally like on the ground versus to the sky? Like, how do we know that you're actually facing south in relation to that map to then have to explain the phenomena?
Well, because I could see where we were through GPS, and you can see on the island, so Kangaroo Island is an island, right? So we had to go out to the island, and it only has certain sides, and we were staying on one side of the island, and so obviously we could see that we were not on the other side, which was toward the north, and we knew that because when we took the ferry over to the island, we came off of a certain part of Australia, the southern out of South Australia near Adelaide, and then we came onto Kangaroo Island, and we went towards to the left, and on either a globe Earth or a flat Earth map, you're still going on to one shore side of.
So long story short, you use GPS, right?
No, because we could see. We drove 10 hours from Geelong, Australia, in Victoria near Melbourne, all the way over to South Australia.
You know,
And so-
if the circle was like 5 miles in diameter, you wouldn't even realize that you're making a big circle, right? That's why people get lost in the desert constantly. So I mean, to say that you know definitively the orientation that you are, based on like something like the GPS, or that we were just traveling and it didn't feel like we were turning left or right. That's not very definitive, right?
Well, there was no inaccuracies. I mean, there was nothing to say that we were wrong, and we never.
Well, if it was backwards,
No.
let's just for a moment, and I know that we're going into conspiracy land, right? We make no bones about
That's
it.
fine.
There's a conspiracy, right? If there was a conspiracy and we're dealing with something that is a projection from reality, I mean, why wouldn't they make it accurate, right? People would figure it out immediately if the maps weren't adding up. But I would add that people actually aren't navigating using a globe Earth, right? They're actually navigating using flat maps. Most commonly, the Mercator projection, 99% of maps are flat. There's only one map that's not, and that's a globe, and it's not even really used for navigation, right? When it was, it failed, and they had to invoke a changing magnetic field.
Okay, but this is kind of hard to discuss because I feel like it's so like point blank. Like even if the maps were distorted or the GPS got me to the wrong location, I was still on a certain, like I could see the coast. I was on the beaches, and you could see the consistency with that, with satellite imagery, with GPS, with maps, with compass. I mean, it was all, there's nothing wrong with it, I guess.
So first, compass. When navigators are using compasses, they're in the south. The farther south they are, the more out of sync they are. They find themselves 20, 30 miles a day off, according to their compass. So what NASA has done is they've taken all those data points and they've programmed them into GPS. Anybody can use GPS, but nobody is allowed to see the source code, because if we saw the source code, we'd say, whoa, why are they making all these adjustments? So you have no idea what direction you're facing down there. But let's pretend you are facing south. That we don't even know if the southern stars are a reflection of the northern stars. We don't know what they are. We don't know what stars are. We don't know anything about them, and their motions have nothing to do with the ground that we stand on. Can you admit, if we're on a ball, that there's physical curvature?
Yes.
Okay. So if I'm on and wherever you are, let's just say it's the top of the ball. Okay. So I'm here on an airplane, and I'm looking at it's a perfectly clear day. I'm on the runway, and I can see stars on the horizon. So I'm looking this way, and I see stars right on the horizon. Right?
Yeah. Right.
I'm in Germany, and I'm going to fly to Brazil. So I'm flying down over the ball, and when I get down here, those stars that were on the horizon are now over my head. Right?
Well, it depends. It depends, like how much the Earth is rotated at that point. But yeah.
Well, the Earth is rotating this way.
I love these globers. I love people that try to really explain their stuff. It's just all speculation. People that try to aim for actually being smart. It's like, I'm intelligent. Like, what do you mean by you're intelligent? Because I know mathematics from someone else. The armor right there. 2 ammo packets. Should be 3. 3 ammo packets.
Armor here. Watch out! Watch it, more of that. Big boy pants today, or big girl.
Yeah, the minigun would do a lot better. I just kill with one fucking clip. Yeah, you can get it. I can't get it. Let's get this one for now.
Anyone need
But
ammo?
yeah. Shit is funny though when you listen to people try to explain the globe and they can never actually explain it. Just get your heads up, dude. Shit's not real. It's all propaganda. Schooling is to try to separate the minds of everybody. If you don't pay in to gain knowledge, you're stupid. They'll give out all these explanations and all this crap that don't make any fucking sense. When they give out all these explanations, they sit there and make up shit. What I mean by that is, you fully can't understand something unless you have it in your own eyes. What we see is what we see. We can't explain
Anyone need ammo?
anything different than what we see.
Cloaked enemy. Just gotta make sure. Right on. Is open. Spend your dash and shut up. There are plenty more squids where that came from.
But yeah, this is what it is. If you can't explain it through actual images, actual, like, camera footage and that, I suggest not do it at all.
Does that okay there, sir?
That's not the way.
To alleviate yourself.
It's just with anything. It's with everything in our world.
Wave 7. Damn, look out! Oh, fuck it! You twist. There's plenty more shit. I'm making the best ever!
Yeah, well, that's pretty quick.
Not that it will matter. You'll still die. You lived. I'm not impressed. I'm disgusted.
Yeah, that's why I don't like about mathematics and shit. People try to aim for using mathematics too much. And mathematics actually don't solve any problems. You can just make shit up and use mathematics to confirm the bullshit you just made up.
Feeling for me?
What's wrong with?
Anyone need ammo?
I want you to get bored, so I made something special for you.
Got a cloak! I'm a natural.
That's most of the way.
Gotcha!
Just head to the pod.
Yeah, this guy get into a corner, just keep on firing.
Do you know the resource cost of a flesh pound? No, of course not.
I found ammo.
That's how I get that sentry. Yeah. C4, it contains explosives. What? I mean, this is an energy drink, right? gigantic rivers underneath there. Yeah, they go. If you go like a mile down, they're gigantic rivers.
That's how they do the journey to the center of the earth.
We watched that documentary, I saw that 5-hour one, man. The last part, it talks about Enoch. Enoch specifically states there's 4 realms of the earth. We live in a moral realm of the earth. Why they say that they always say our North Pole always moves. Well, every time it moves, it gets closer to melting the ice around us. They're afraid to melt it so we can see the other lands. But basically, you got 4 things. You got the earthen realm, the debris realm. They actually explain each realm. So we're the northern realm, the southern realm, eastern realm, and the western realm. That's how you get cardinal directions. What happens is the big iron mountains in the center of all 4 realms. It's an earth realm, but they separate by realm themselves. And you know how they always say true north? They say true, that is true north.
So the North Star don't.
No, North Star is the true north. Because they say you can't go true north unless you fall celestial. Because the North Star is true north. So you got the 4 realms of that. We're north. We have our magnetic pole. That's moving. So we still have our star system. Everything's going to stay the same. Our North Pole is moving. So the middle of it is when the vortex that where all waters meet. They're supposed to call that the paradise. No, probably more or less the Garden of Eden. That's what I'm speculating.
Yeah. Nobody knows that.
Well, no, he didn't banish it. It's just
Advantage of it.
for mortals he banished it.
Yeah.
We're not supposed to know that it's there, but I mean, obviously they're there.
Well, they say it's good.
Well, yeah, it's because they're stuck in a. So that's basically what Enoch is saying. You know when Jesus walked through the valley of death? That's a road. It doesn't road. Walk through the valley of death, you see him with double on his back. That's a road that we have. Yeah, so there's different roads that have an actual like celestial road that has like I don't know if they're angels or they're just like God put them there for a reason. I guess they're angelic. They're supposed to walk over there every day. Yeah.
That's why when things happen, like, it's like, like the scary accident. We had an agent that I know, you know, you know, this, some kind of guy got, decided to have to jump on that.
Well, basically what it is, they use, what I'm assuming, when stuff happens to someone that's special is not supposed to die, God interferes with angels, which makes sense. We're not meant to die. We have something more to give to humanity, and it's in His word for us to stay alive. That's kind of the point of when we have to learn to keep it on our spot. There's a reason why we stay alive. We would have flipped into it. There's no reason for us not to. Yeah, basically, it's basically pushing us out the foot. Sometimes, like dirt and grass, the hills like fucking like this. You would have flipped into it. You would have flipped into it. Because all that grass, dirt on the hills. Yeah. So if something was pushing on us to get us to slow down or not, it's where we're going to flip. That's all I can explain with that. Yeah, because that makes no sense at all. Physics, you would have flipped instantly. Excuse me, guys. I'm having some booty hole issues, like some of those old ladies do at my work. Man, them old ladies wreck that damn bathroom at work. It's terrible.
Not this way. So I'm going from the north. right? The stars on the horizon. If I stayed there, and the Earth is rotating, those stars are going to stay there.
That's right.
If I go down, those stars should be on the top. So I want to show you a video that a pilot gave to us, and this is from Germany to Brazil, and it's a time lapse. And you look at the stars; they're not rising up. You would think that they would rise up, but they're just the only time they move.
Yeah, that's an awesome example of him going along with the Earth's rotation.
No, so this is what Google Earth says that flight should look like, right?
Yeah,
Google Earth says
Google Earth isn't rotating actively.
it doesn't matter. The rotation, the east-west rotation, has nothing to do with north-south navigation. The stars, as he's diving over the Earth, these stars should go up. So this is reality versus Google Earth that is simulating what we're supposed to see on a ball. There's a problem. There's a big problem there. This is what it should be. These stars should just be rising up as you're diving over the ball. Whether it's spinning or not spinning has zero.
Dave,
If you hold on, if you were flying east or west on the equator and you had something on the horizon, yeah, you're flying towards it. It's going to go up or down slower, but north-south has nothing to do with the spin of the Earth.
Wait, you said he's going from north to south? Are you saying he's going to north to south in that?
Yep, north to south. Yep.
Yeah, that's
Okay,
why
where
you
does
see
he
the
fly
stars
from?
rotating this way.
Where was he flying from?
From Germany to Brazil, I believe, or somewhere. Germany for somewhere down there, down below the equator.
Okay,
Okay.
Ha!
I'm trying to think.
And you can think. Here's one. Think about it, and maybe
Well,
not. Right
I just think, Dave, that the answer is the Earth's rotation, and so to say that has nothing to do with it, like
That's all you can say because you don't know.
That happened.
Well, let's look at the Earth's rotation. You got a plane here in the north. Let's call that Germany, and they want to fly here. Okay, right? But the Earth is spinning, and by the time he gets here is now over here. So he has a choice. He could kind of keep correcting to the left, and chase it all the way over. Or he could say, you know what? I want to go here, so I'm going to fly this way because by the time I get there, here will be there. Okay? No one ever does that. They take their location, they say it's that way, and they head in a straight line.
That shit's
and
so
go that way
funny.
directly to the location. Okay? If the Earth was spinning, you got a problem, right? But the spin of the Earth, you gotta model it out. The spin of the Earth, east and west, have nothing to do with that observation.
Okay, let me show you guys something. All right, so before you got on this program, I need to tell you that it's extremely reliable. I think it
Goes off the attitude.
well, no, it does have an attitude grid, but no, it's just walking. So this is close to where I was in Australia, so you can kind of see the same thing that was in the video.
The ground curve like that where you were? Did it swoop up
No,
like that?
obviously, like if you zoom out all the way, like it's just a matter of point of view. So really, it was probably closer to something like this, because it was a wide-angle lens. But otherwise, the reason I had to do that because otherwise you can kind of see the amount of the. But the point is, this is looking directly south, right towards the South Pole. And I want you guys to notice the specific stars that we have here. We have the LMC, which is a large Magellanic Cloud. We have the SMC, the small Magellanic Cloud. And in terms of the Milky Way, you have the core there, and then up here you've got there's the crux.
So we're not even really looking at the sky here.
No, but if you went to the same location and looked up, this is exactly what you would see. So this is a reliable software program or software.
Well, let me just, before you finish that point, if I put you in a planetarium and it showed you those same stars in the same locations, would that mean anything?
Well,
Would that
hold
mean
on.
the Earth is a globe?
Well, so sort of, because
So
this
the
is
planetarium proves the Earth is a globe. Because you're on a floor in a planetarium. You're looking at light to the sky that are 50 feet away from you, and you think that they're millions of light years. Go ahead.
Dave, I need you to be charitable with me here a little bit, because What I'm saying is, if what you see in the planetarium is the exact same thing as what you see in real life, then it's reliable. It's not just because you see it in the planetarium. Okay, this is just what I can use because obviously I can't take you guys outside. But this is, so in the southern hemisphere we have, that's the southern celestial pole right there. So all the stars are on the bottom of the globe in Australia, and you're looking down towards, towards the downwards.
Anyone need
from
that weapon?
From a right side upward anyway. And then here we have where I am. And you can see totally different stars. You can see, so this is the literal opposite side of the Milky Way.
Yeah, you use software that's made by NASA to show you where the stars are at.
Actually rotating counterclockwise around a different point. These are different. You didn't see Cassiopeia, you don't see M31, you don't see, the Big Dipper, you don't see Ursa Minor, you don't see any of these. And this is looking directly north, right, to the North Star. And all of the stars rotate around the North Star. So you have the southern hemisphere where it rotates counterclockwise, and we have all of these constellations. They're beautiful and whatnot. I'm sure we could all agree with that. But they're totally different stars than are over here. Totally different.
So if I may,
different directions.
explain that with a phenomenon that's not the Earth actually curving, right? And just to narrow it down, right?
That's the point. Yeah.
Of course, Joel. Your claim right now is that the way that the stars are moving, right, and the way that they appear to be curving around the Earth, right, is evidence of the Earth curving, basically.
Not the Earth. It's evidence because if you were on a globe and you were looking out from that globe, you would expect to see certain things. So if if you're on the North Pole, you look straight up, you can see the stars rotating directly above you, and you wouldn't be able to see the southern hemisphere. And so, when I took the flight down, I went from Dallas, Texas, down to Melbourne straight, and I got footage of a night lapse of the stars moving, similar to how that pilot did, except I was looking out the side of the airplane. And I can see the stars literally shifting orientation in the sky as I was crossing the equator and stuff.
Okay, so let me simplify it even further. Then, in your worldview, is perspective an actual thing? Do things get displaced in relation to the viewer based on how far they are in their relative position? Right. So, in other words, even if we're dealing with a flat plane, right, if something is moving level parallel overhead, optically, to the observer, would it not appear to drop? Or would it still appear to drop because of perspective?
In terms of something getting further away from you, that's has a certain height, and the further away you get, sort of looks like it's...
Yes, two parallel planes.
Yeah, you see that with train tracks, sure. Yeah, the distance...
So what if the stars were close and local, and you're flying underneath a low sky? You would see the stars curving over you as you go by. They would drop down lower. They'd be high above the plane as you're flying, right? And the reason that you see different stars is simply because the stars are so close. If you and I were in a room with 10-foot high ceilings, and there's recessed lighting, and they're in all different patterns. Look, there's a starfish, and there's a bull, and there's a cow. And I say, hey, Joel, walk 5 miles. We're going to expand the room to 10 miles wide. You go 5 miles down, walk there. So I wait, a little while, and I can't see you anymore because my vision has brought the ceiling to the floor, and you are too small for me to see. So I call it, and I yell, and my voice spreads out, light spreads out, and you can't hear me. So I call you on your cell phone, and I say, Joel, are there still lights above your head? And be like, yeah. I see a horse and a dog, and I'm like, well, what happened to the cow and the bull? Well, I can't see those. Okay, you can't see the stars that I'm under. I can't see the stars that you're under, and we're just 5 miles apart with a plane in a small room with no atmosphere causing issues. Just perspective. So that's why you can't see the same stars from the south, because they're too far away. The problem is, on a globe Earth, there's a physical horizon. A physical horizon. So on a globe Earth, if you use globe math, you love math, there's a certain distance, which is the max distance you can see. Never, ever can you see farther only if conditions like waves on the water or density of the air could you see less. You can never see farther because it's a physical horizon. On a flat Earth, our horizon is very optical, and depending on weather conditions, we can see farther than we should be able to see. So, you know, a 6-foot-tall person standing at the edge of perfectly calm water on a perfectly calm day, perfectly clear day, should only be able to see the surface of the water for 3 miles, according to your math. Okay, there's a 6-foot drop in 3 miles, according to the Pythagorean theorem. Okay,
Got a weapon
so
here.
I should be able to see the surface of the water, but we can see the surface of the water for magnitudes farther than that. We can see things magnitudes farther, right? But globers like to say, well, I can't see that mountain. I can't see that mountain, therefore the Earth is a globe. And then we break out a infrared lens, and all of a sudden we're like, oh, we can see that mountain with infrared. And infrared, and the only thing they have is screaming refraction, refraction. But infrared even cuts down refraction, right? Without an infrared, you see a blue sky, right? But we can see this mountain with infrared. And infrared, if it's refracted up, it should be even less. But we can see all of this mountain except the lower part because the atmospheric density. So we can see too far because the horizon is a theoretical limit of your vision, okay? It's not a physical horizon.
Yeah, but what about the rotation? Because that's specifically the
What the rotation?
So the rotation
of
so the rotation is so this is something that I've actually been trying to send you something, Dave, for the background, because I can't share my screen while I'm streaming. Otherwise, I'd pull up the visual for you. But we actually
where are you sending it?
Well, no, it's just too big to send. So I was trying to send it in my email, but it doesn't work. But anyway, in any case, Walter Bislin actually did us a favor on this and actually modeled out what the stars would kind of look like on a flat plane. They did use arbitrary stars, so it's not like you can see specific constellations or anything like that, but it basically just shows the general position of where the stars were and then what it appears to be optically to the observer. The reason why this happens is there's a huge discrepancy or a miscommunication in what we're actually dealing with. So we're dealing with measurements in our visual field. Right, we're dealing with things that are very far away, and there's a big assumption that everything is in Euclidean geometry. We assume this because for a lot of things it tends to work, but if you Google it right now and you look up the geometry for visual space, you'll actually see that there's not a set model for it. So, oh good, they've got it pulled up right there, perfect. So there's actually not a set model for what the geometry we should expect to see in visual space is, and there is now evidence coming out that we are seeing a hyperbolic geometry as our visual space. In other words, spherical geometry. There's something known as the Alley experiment. There's a paper that is referenced that I also sent Dave a quote from. And this would explain the spherical nature of what we're seeing. As far as the rotation goes, it's an optical phenomenon. So it's literally an optical phenomenon. You would have an optical convergence point at the furthest point away from the center point of rotation. Because again, the further out that things get, the more they're going to tend to converge. So the things that are rotating above you are obviously going to, if you're over the equator, actually it's going to appear more straight. And then as you get further away, it's going to optically converge again as you look out. So this is just one of the explanations. Another explanation is that there's literally 4 different optical rotations, which is very possible if you just think of it as like gears, right? You have one rotation in the center and then 4 opposite parts of rotation coming off of that. So, but before I even attempt to explain any of that and get into the bottom of what's happening, I like to start with first principles, which is why I had asked you, how do we even verify the general position of where we're looking definitively, right? There's the quote right there: Euclidean geometry widely accepted as the model for our physical space. However, there's not a consistent model. There is evidence that our eyes work to make pictures and images of the physical space using a hyperbolic model. And this is obviously what we're basing our measurements off of. So I'm wondering what you would say to that. And if this is true, where is this accounted for in the mathematics that you present?
Well, there was a lot there. I got some stuff down. It certainly wasn't any simple sort of a message that you just gave there. So you're talking about non-Euclidean geometry.
Right.
Okay. and how that relates to our sort of more hyperbolic perception. But you mentioned how, so for example, if you're on the equator and you're on a globe, you would expect the sort of the stars in the sky to sort of barrel over from you have the north here, the south here, that barrel over you just the same way. If you turn it right side up and you're on the North Pole, the stars would just rotate around that top point. If you're in the South Pole in Antarctica, you look up, it would be the same thing, but with different stars. So my question is, with what about the different stars? I mean, they're completely different, and you can watch as you traverse the globe the different stars.
So that issue was actually solved before the rotation issue was even solved, right? So what happens is, because our visual space is curved, the things that are further away are obviously going to be dipping down. So what ends up happening is these stars, the stars that are over, let's say, the northern hemisphere, as you drift over the equator, you're going to start to see both of them. Because, again, the closer you get to something, the more it's going to rise up to your perspective. The further away, the more something's going to fall. So as you move away from the northern hemisphere, those stars are going to fall to the horizon and become invisible to you. And then the stars that were invisible to you, that you moved closer to, are now going to be visible to you. Long story short, let's pretend you're in a big warehouse with lights over top. You're simply underneath one set of lights.
Yeah. You're 5 miles away in the same room. We look up, we see the different stars. Now, as you walk towards me, you can't see the stars that you left behind, and you start to see the stars that I'm seeing. You're on the north side of the room, on the south side of the room. Okay?
So
it's the same thing. What's that?
How low are these stars to be?
We don't know. We don't claim. But you know. I know that they're 25 trillion miles away. I just made that up, right? But your theoretical, ideas of where the stars are scientifically impossible, if you ask me. Our stars are very close. I don't know how far they are, but I don't think they're thousands of miles away or millions of miles away. I don't know. I'm not going to make a claim.
Well,
I like looking at things here on Earth that we can actually measure.
This is just a question. I'm saying, so if you were to measure and work out the math of how far something would have to be to go a certain distance away from it to where it looks like it goes down.
Well, here's the problem. You've seen the orthographic view of the flat earthers say the sun's 3,000 miles up, and with the size that they say the earth is, the sun would never set. Well, I don't think it's 3,000 miles up, but even if it was, they're not taking into effect that somebody standing under it is directly above them at X height. Now, somebody farther away, it doesn't stay at X height. It gets lower already, just due to perspective. And they go farther away, it appears lower and lower. Okay? Phuket Word, you don't know who he is, but he recently did a video on it, and it's really, it's how perspective works. They don't teach perspective in school, but if they did, people would be like, wait a minute, this doesn't work out. We don't live on a crazy globe. I want to get back to, you're talking about seeing the stars stuff. The stars, we can't prove what they are. We don't know what gases they are. We don't know how far they are. The brightness is 2500 times brighter than the sun. That's a made-up story.
That's only one star. There's different ones that have different.
If you told me something was 1.5 times as bright as the sun, I'd have a hard time believing it. Okay? Because the sun is, because you have no examples of anything brighter than the sun. Let's say, they could do something in a lab, and they say it's 10,000 times brighter than the sun. Show me something twice as bright as the sun. They've never, ever done it. But instead of looking up at these lights in the sky, let's just come back down to Earth for a minute. You agree there's a physical horizon. You agree that there is curvature of the Earth. Do you know anyone in history, or have you ever measured the curve of the Earth?
So the second question, no. For the first, I would say yes.
Cool. Well, and the other one is axial rotation. Do you know anyone in history that measured axial rotation, and can you tell me how?
Axial rotation? What do you mean by that? Like
the Earth spinning on an axis. The Earth spins on an axis.
What do you mean measures that?
They prove that. How do you prove the Earth spinning without looking at the lights in the sky?
What do you think would be a satisfactory answer for you?
The Earth isn't spinning.
If we were to have a test of this.
If the Earth would,
See what it is? You just don't know, and you're trying to explain something you don't understand. Because you know. I love these Globers, man. This is why I tell you, it's like, don't believe anything until you see it with your own eyes.
Thank you, me.
For real.
Protect the area if you can.
If I can. Where's that? Right here? Oh, yeah, I'll do this one. I hate them damn crawlers. I hate throwing my gun down.
Got ammo.
That's bad. That little guy helps out a lot. Not too bad. Could have been worse. Minigun does really good with that maximum size. I don't think anything's really better than that. I mean, the grenade launcher thing is really good, but minigun's just got a lot of bullets to it. Bullet.
I'll see if I can get your fingers stuck in it.
But yeah, it's funny listening to people try to explain nonsense science.
I found ammo.
Punch it down.
I don't know where I want to go at. Where's that house at? I think it's over here. Yeah, it is.
With your teeth.
Is it?
Anyone need ammo?
No, it's not. Fuck. I'll stop right here. Oh, fuck no. You guys for real? Dude. Tell you about these spawn points. I swear to God, they just drop spawn these fucking guys. I killed one of them. I know they do drop spawns. That's good. I couldn't do nothing about that unless I was a berserker. We'll do spillway on spillway. That's okay.
What that spitting or curve, you'd be able to measure curvature. So let's look at this. Okay, so when you're down low, the thickest part of the atmosphere, you can't see 100 miles. Okay, because the atmosphere just becomes too thick, right? But the higher up you are, the air is thinner, clear, less pollution, less moisture, and you can see farther. Here's an observation from a mountaintop.
Oh, yeah, I watched that video. Yeah.
You watched it. So what is your explanation on why we can see these mountains? We can see all of them in the right places and everything. The tops of these mountains should be over 40 miles below the curve. Now you can say, well, the curvature calculator is wrong. It's a parabola. You can say whatever you want. Oh, it's the hump. It's the Sagitta. Okay, only 20 miles. The tops of these mountains, which is nonsense, should be 20 miles below the curve. But we can see them. What is your answer for that other than refraction?
I'd have to look into that. I can't just look.
You know what? You would be the first one with a scientific belief system that is willing to look in it, because mainstream science won't look into it. No one will look into it. Okay?
Yeah, I mean, I could look. We'll jot that down for next time. Then.
There you go. Come up with an explanation on how we can see all of these mountaintops.
Okay. Yeah, I will.
All right. Beautiful.
See, that's amazing.
You assume on faith that the curvature calculations are just going to work out. It's just going to work out.
I never said I'm gonna. Okay, but Skylar, you gotta give me. I mean, how would you work it out then? I guess
there's a curvature calculator, right? So I would simply find the hypotenuse. I get the distance of the observer here, 700 miles, the height, and then I would plug those numbers into probably the Walter Bislin Earth curvature calculator. And then I would invoke standard refraction just to be a good sport, right? and then, I would see what figures it gives me, and then I would compare it. When you do compare it, it says that there's 80 miles of shows. These mountains are about 80 miles high. So these are the things that to us, seem to falsify the model that everybody just keeps insisting on with hypothetical, celestial proof.
Well, I think celestial is strong because again, if we are in space, you should be able to look away from it and be able to tell, and be able to predict what you can see.
But the whole thing with the assumption of Euclidean geometry being shattered doesn't shift or make you want to relook into
the way that we're. I don't think it's shattered. I mean, obviously they just said there's alternatives. There's different ways to mathematically like the difference between radial.
No, so when I say shattered, right? I mean I don't know how they can get more shattered than well they nicely did it right. They said the assumption of Euclidean space is wrong. And we have evidence that we are building our space with hyperbolic geometry. So I'm not sure how we wouldn't consider
I actually think that's actually math, tensor calculus, and general relativity. That's using Euclidean for criticizing.
This all was done as a result of Halley experiments or terrestrial experiments, right? So we're not dealing, when they did this observation, they weren't even using celestial observations, right? So this can happen in the small scale, which is, again, this is the kind of stuff that we like to go on when you say that, well, yeah, both sides are taking something on faith. Kind of, at least our side, we have the ability to go and verify the terrestrial examples, whereas your side, we have to take on faith that this entity, NASA started by Project Paperclip, Nazis admittedly, sent probes out and gave us back the correct data.
Yeah, I mean, but I guess, because then I just asked, what is this thing? What are these?
Would you accept that we don't know, and that maybe the people claiming to know are just trying to get a leg up credibility? Or that maybe you've been misled the information was, and that people who are actually doing the work on the ground don't claim to know this, right? They claim that this is a theory that could explain the phenomena, but it's a work in progress, and it's surface level at best, right? It doesn't even begin to explain the deeper phenomena. Like you can't explain the gravity, you can't explain
we can see other galaxies.
No, you see lights in the sky that somebody told you is another galaxy.
No. You can see the shape. You can see
a shape that somebody told you is a. Did you take that picture behind you? Where's that picture from?
Yeah, I got it. Yes, I took this picture.
You took that with your camera.
That's my GoPro. Yeah.
Your GoPro took that picture of the sky.
Yes.
That's a great picture. Good job. You're taking pictures of lights in the sky that are not hundreds of trillions of miles away. They're close. They're close. But to assume that, that's a disk shape and it's kind of fuzzy, therefore it's 100 billion stars with 1 trillion planets. right? To believe that's just a belief, right? So here's the example of before. Okay? Is this the sun or the moon?
I can't tell. Probably
Is it a sphere? Is it a sphere?
I also can't tell.
Okay, that's right. And guess what? It's only about a quarter of a mile away, and as we bring it closer, you see that it's a train and it's not even a sphere. Okay? It's got rectangular lights on it, right? It's got orange lights and different color lights. But you saw a sphere at a quarter of a mile away. But you think that you can see a light in the sky 100 trillion light years away and tell me what it is? You couldn't even tell that this is a train with 8 different colored lights of different shapes that are not even touching each other. It looks like a sphere. It's how we see.
Yep.
But what about things that are shaped like what we call galaxies?
They're shaped like what we call, you know what? An egg is shaped like a galaxy. I don't think there's 100 trillion stars in my fried egg in the morning. Galaxy? It should be. It should have 100 trillion stars in it, and it should be amazing. I bet if I took a really close-up picture of it, I could send it to NASA, and they'd be like, "Wow, you discovered a new galaxy."
I mean, okay.
I'll take it okay. I'll take it okay. That's all you need. That's all you need to do.
Oh, it's just too funny.
But here, I think I made a good point. You couldn't tell what shape this was, what it was, or anything at a quarter of a mile away. You think that you can tell what something that looks like? They say, "Hey, a galaxy is this shape." Okay? You think that you can tell what that is? You were told what it is, and therefore anything that's that shape, you believe it because that's what you were told. There's zero evidence for anything that you have brought up today. It is all theoretical. Getting back to the spectroscopy experiment, I want someone to do a I can't say the word, spectroscopy experiment. You get a vial, we should be able to get a beaker full of whatever gas, put a bright light behind it, set it on fire, whatever you want, and somebody a quarter of a mile away should be able to tell me what it is.
That's not how spectroscopy works, though. That's not...
How does it work? we already went over this.
Yeah, we already went over that. But, okay. So let me just one more example on that. So this is the same program. I've seen these things myself, so I'm not like I'm just showing you gibberish that I haven't seen myself. First of all, I'm sure you've heard the Andromeda Galaxy. That's our nearest galaxy. It's quite large. I've seen it. You can see the shape. I can make that example right now. What's that? So I can make that example right now. Yeah, but I'm not. You can't say this is fake, Skylar. This is real. I've seen it. This is like some made up. We have pictures of. You can go outside of the telescope right now with a DSLR camera. Put a star tracker on this and take a picture of it. So this isn't like some made up thing.
You said we can put a
It's a
star
light in the
tracker.
sky.
How is it that we're keeping up with this other galaxy, right? That's definitely not within our galaxy. And when we're whipping through space over 1 million miles per second.
Well, space is really big. So here's another one. So here's a Whirlpool Galaxy. You've seen this one.
Because
too.
space is really
You can see
big.
the shape. You can see the
This dude's trying so hard to be smart, but it's not working because he's not actually using actual evidence. He's using what everybody else is using.
Skylar, what if there was a book that said that these are spiraling lights that were just a couple hundred miles away, and that's what you were taught? Now, if I showed you all these and told you that there were galaxies trillions of miles away with hundreds of billions of stars that are bigger than... But my point is, you could defend either one of them with an equal amount of evidence, which is zero.
I'm saying so.
Try not to do a spit take.
It's just. It's sort of like what you're calling it. It's just a matter of it's like semantics of what you want to say that it is. And then, of course, this would be our galaxy that we're inside of. So we're inside. That's the center of it, and you can kind of look away from it. So this is our Milky Way, obviously, and any of us could see that.
It's not obvious because you were told that. You're pre-assuming.
No. I'm saying that this is all stuff that you can go out and see yourself, and then you can.
But you couldn't tell what a train light was, right? It's a cool story, bro. It's a cool story. So you have zero proof of it. You were told that it's a galaxy. You were told that it's trillions of miles away. You were told it's 2,000, or you figured out on your own that it has to be 2,500 times brighter than the sun. These are all things that you have zero evidence of. Zero.
But wouldn't the evidence be the observation, like looking at it?
Yeah, observation. As I said before, if you were taught in school that these galaxies were actually energetic sources of spiraling light that are, a couple hundred miles away, that would be your story.
Oh, hey,
There's another one.
One of the biggest debates in astronomy was actually this exact point. When we believed that the Milky Way was the entire universe, and we didn't believe there was other galaxies. We didn't even know what a galaxy was. And so, I'm still here. I'll be right back. Okay. So the point was, it was called the Great Debate. You can look it up. Where it was Andromeda, that first one that I showed you. They were saying, oh, that's actually not a nebula. They thought it was a nebula. And turns out, well, Hubble discovered that it was a galaxy. You could look up how he did that, but
so they changed their story. They literally just changed their story.
well, I think it would better term would be updated.
Hands up if anyone's
So that would be impossible to mention in any kind of how can you falsify the model if you just want to change it whenever you hit narrow down?
It wasn't falsified. It was added because they didn't deny that the Milky Way existed. They just said
Kind of like
Oh,
refraction. Kind of like refraction was added to save Earth curvature.
well, you and I both know that refraction is a thing. Like you can see how refraction works.
So
You can
Refraction never brings anything up that's gone. It can move things that are in your visual range, but it doesn't bring things back from when they're completely hidden. Keep them there over 24 hours.
I'm just
using weather
saying
conditions.
refraction itself is a thing.
Refraction, but that doesn't explain the observations. For example, the famous shot across Lake Michigan of Chicago. There's a time lapse, 24 hours with different weather coming through day and night, and the buildings never move 1 inch. They're just there the whole time. And we proved that they're not refraction because a couple of our guys got in a boat and watched it and went across the lake, and it just disappeared at one point because they're getting closer to it. The refraction should change, and it never changed. We proved that it's not refraction.
But all I'm saying is, with the Great Debate, it wasn't falsified and debunked. It was just added up to go, oh, I guess that the universe is way bigger than we thought it was.
Well, that's, again, theoretical nonsense. You believe that this is a giant star manufacturing factory where there's dust and gas in space, another scientific possibility, that is collapsing upon itself and spitting out stars like we want balls. Okay? That's what you believe, right? This is a nebula that produces stars.
Yeah, the pillars of creation. Yeah.
Yeah. So cool story, bro. It's a cool story. It's not even a cool story. It's ridiculous. Okay? How do you have gas and dust in space?
Well, I think we probably won't get into that topic here. But
When you say things like, well, the observations are evidence, right? Do you know that we changed the distance to the sun like over 7 times in modern history?
yeah, probably. We updated it. I think we got more refined.
Do you know why that's significant? Do you know how much they changed it by first off? Like, you know how much they changed it from?
No.
1,000 miles was the first predicted distance. So they have.
By who? Who did that?
I can't remember the exact names of everybody who did the predictions. But in any case, we end up now, obviously, with our figure of 93 million miles. You admitted yourself that, they probably changed it to update it, right? So here's the issue. We base our very important unit of measuring all these other distances off of our perceived distance to the sun, which was the astronomical unit. It's also how we defined our speed of light, right? We simply define it as constant. We think that the sun is so far, and then we measure differences in angle. So it's pretty funny that we don't actually have in my opinion, a real measurement, a direct measurement of light. Is an inferred measurement. But in any case, the AU was changed 7 times, which means that the units to all the other stars were changed several times. And now I mean, this point was kind of breezed over when Dave brought it up. The North Star, they're talking about give or take, right? That means they could give it 100 million or 100
100
more
light years.
Yeah, 100 more light years, or take 100 light years away. That's a 200 light year discrepancy, and we're going to sit here and pretend that that's not going to have anything to do with the other predicted distances when we know that several other predictions were made about the distances to other galaxies and other stars based on where our projected distance of the North Star was. It's a house of cards.
Still, mainstream science, if you don't agree with them, you don't get published. So mainstream science tells us it's 93 million miles away. But during one of the recent solar eclipses, a bunch of truthful, honest, researching amateur astronomers said, "Hey, they did the math, and there's something wrong. The eclipse doesn't work. The sun has to be farther." And I forget the number, but it was significantly farther. And so all of these chat groups, these articles started popping up, and then they all disappeared. Inside of a couple of days, bam, you can't find any of them. It was completely squashed off the internet. Well, wait a minute. There's something wrong with the eclipse and the shadows and everything. It didn't line up. And that was just squashed. I know everybody heard about it.
It's interesting.
It is.
But would you be able to acknowledge that, again, this is why I say it's theoretical at best. I'm not saying that the theory can't work, right? It very well could, but we can acknowledge that the observations on their face are not proof of themselves. In fact, you even stating that is a literal begging the question, or also known as a reification logical fallacy. If an argument is logically fallacious, then that means it's not good support for that claim. Not necessarily that your claim is wrong, but just that argument is not a good argument for that claim. So when all of your arguments pretty much are like that, it's flat Earth and fuel.
No, I don't think all of my arguments have been like that. Not all of them. But yeah, it is a.
You full of shit, bro. Say it.
Reification. Yeah. So.
Make up words.
It's hard. It's. I could scrub through this whole video and watch it back, and I'm sure all three of us have made plenty of logical fallacies in the stuff we said. So it's kind of really, really hard to avoid. But yes, and to your point, it doesn't necessarily make it valid. So I guess it is a sort of beating the question or begging the question. But I guess that if I acknowledge that, I also like if you guys could maybe acknowledge that if on a globe model, those celestial movements would make sense if it was a globe.
Which one
The rotation. The rotation, the celestial rotation. It would make sense on a globe.
Yeah, I'd give you that.
Okay. Yeah. All right. Well, I think this was productive. It was very involved, very in-depth.
There was a third question I wanted to ask you. The one was axial rotation. No one's ever measured it. The curvature, no one's ever measured it. And high pressure next to no pressure. Have you ever seen or heard of a test in a lab or in nature that can have high pressure next to low pressure without a physical barrier in any orientation?
Hold on. Is the question high? So the question's high pressure next to low pressure.
Yeah, without a physical barrier.
Got him. Got him.
Let me see. I'll write this one down too.
Ha!
The thing is, when you start talking about these things, you have to start using things like Boyle's law and fluid mechanics and all this stuff that is mathematical. So it's hard because when I sort of like start.
Oh my God! No one cares. Do the fucking experiment. Why do people hang on to such ideology, or the fuck that word supposed to is? Why do people hang on to stuff so much? When a lightning bolt strikes somewhat near you, and you feel a static charge,
Must be the cleaner's day.
that's all you need. You felt the static charge, you know it exists. Same thing with your eyes. When you see something, you know it exists because you see it. Science trying to falsify our sight that's been given to us by the Creator. It's just sad. Yeah! Got him! That was pretty epic. Fuck that dude. You want, bitch? Boom! Yeah, this is where the commando actually becomes extremely good after level 20. Once you get this magazine size, it's astounding.
I found ammo. Great, everybody.
You are so dead. The next wave is gonna flatten you. You're not dead. Good enough.
Got shiny new Kevlar here.
Yay! That shit's funny. But the whole point of this, when people can't explain why they do the things they do, and never know exactly what's going on. Another Kevlar, holy shit, two of them. This is the reason why when I talk to people in general about anything, it's not even about Flat Earth, and I don't give a shit about that. It's just the mindset of people who want to never explain why they do stupid shit, or why they say the things they say. They just keep on pushing a narrative about who they are, about certain things, and they never stop pushing the narrative. So someone says, I lift a lot of weights, and you look at them, they don't lift weights at all. Where's the proof of it? Someone said I did it. So this is why people take video proof of them lifting weights. Or they show some type of thing. You could just tell by looking at someone that they lift weights. They show them proof by the way they look. Look. We always say, I look at something, or I see. That's the dedication of proof. Yeah, this is why people always get so offended by stuff like that. Jam in the deck! Ah, he smothered me with his huge dick and balls. Ha! Just got cock slapped. Just playing. He makes them all eunuchs. That's sad.
They've got a sort of red motif thing going on.
Yeah, this is what I don't like. When that's what the whole point of these arguments are with people in general. So if someone does something wrong, they never want to admit that they do something wrong. They don't want to admit that they are wrong. They want to keep on believing that they're smart. Dude, you can believe anything you want, but believing that you're smart is stupid. I always want to say, if everything was faked, and you can figure out what reality really is, don't you want to figure it out? That's basically how our world is now. They want us to be at home, watch TV, and get all the instruction from TV. The TV is literally nothing but a programmer. That's what I call it, program. It's a program. They program you. Ah!
You twitch, ass face.
Guys.
You'll still die. The fact your survival is an accomplishment.
But yeah, this is the reason why it's so important for us to see things with our own eyes.
It's your funeral. Leaving your armor like
No one likes manipulators. Like, I hate manipulators.
Got ammo here.
the central is soon.
Anyone that wants to manipulate a situation to make it best for them. There's the reason why our world has so many problems.
Anyone need ammo?
T-minus 10 seconds.
So, like, every time I talk about anyone, it's just because of how they are. I never want to push anyone into something that's ignorant, you know. Like, if you say, oh, there's a problem with someone. Like, for instance, one of the DoorDash girls came in. She came out Monday. I kind of, like, conversate with her. Like, I flirt around with her a little bit, but it's like, you know, jokingly flirt around that. She's an older lady. She's, like, in her late 30s and that. So we talked about her life and that. And, well, anyway, like, I actually, like, know things about her, like, how she is and that, and things like that. And, so one of the younger girls that I work with, she's a manager that. She's young. She doesn't know much of anything, obviously, because she doesn't really want to gain knowledge. She just wants to sit there and live a poor excuse of life as of being young and not being stupid and having fun and getting fucked up and rotting your brain out, whatever the fuck people want to do nowadays. So, right there, the evidence of why I stated things the way I stated, she was assuming I was trying to pick her up. Once again, like some other streams, that you assume too much when you know so little. So you know absolutely why. You actually don't know anything or reason why I do the things I do towards that person, but you want to establish just because I'm a man, she's a woman, you instantly think the stupidest things, which is always like, oh, sex. And like, no, it has nothing to do with it. Number one, no. But I ever say that she's not my type? I mean, I can never say that she's not my type, but the thing is, I don't want to. So this is what I don't like about, you know, when you're not intelligent enough to know the difference between fictional reality and actual reality. Fictional reality, you think one thing only. You think all men are like this, and men should think all women are like this. That's the true bullshit nature. The reason why you get men and women like that, because they're stupid. They're ignorant, they're uneducated, and they're dumb. You go by instincts more than anything else when you don't have the capabilities of learning how to be nothing else other than the instinctual thing that, you know, it's meant for us to reproduce. That's the reason why people always have problems. They do instinctual stuff, and then the first thing they see something, they're like, man, I'm excited because that person looks good. Okay, cool. But when you actually think about it, I was gonna say, does anyone ever think like, why don't you go after the girls that you talk to? That'd be a valid question, why don't you do it? I'll tell you. I guess I'll have to say I'm celibate. I don't do those things. And the next question should be, the same question as before. Why don't you do those things? Because I see that it's not important in my life to sit there and put my ding dong in everything. It's not important to me. Once again, when it's not important to you, you don't gravitate towards it. Oh my God, I say gravity. Yeah, gravitate. Not gravity. Fuck gravity. Gravity's dumb. I don't gravitate towards those desires. That's what it is. It's desire. When I find a woman I actually like, you'll notice. Because more or less likely, I'll move in different ways. But I haven't found anyone that I like to be more than just, the sexual interactions of, what most people do. Yeah. Holy shit, dude. Oh, he's gonna get close to try to blow me up. I'm gonna dig in. Because the more knowledge you gain as a human, the more you stop looking like everybody else. Like, that young girl called me weird. And all I said is, because I'm smarter than you, that's the reason why you say I'm weird. And nothing after that. It's like, well, yeah, because you don't know nothing. I'm trying to tell you things about your life that are wrong because you don't have a good structural guiding point. You have no one that's trying to help you because your dad's a deadbeat. Whatever. That's why I call a deadbeat person. Our deadbeat person. I don't know much about anyone's family and that. Well, I'll say the way you are presuming, why don't you have someone telling you drugs are bad, you shouldn't be doing them? I would tell you to go to college now. I'd tell everyone to get a job. Get used to working 40 hours a week. Build your strength up to get used to that. Go home, have your fun. That's what I do, and keep on building yourself. Don't ever stop building yourself. Don't ever stop thinking you have to stop learning. But yeah, this is why it's really hard. Like, I was taught to not do drugs. I was taught not to smoke cigarettes. I was thrown into that disability, not disability, but thrown into that discipline. And I didn't do it. I didn't see the point to do it because I had other things to do. So, like, I played a lot of video games. Video games stopped me. People say, well, I don't play video games. That's why you smoke weed and all that stuff. You have no entertainment value that's going to keep you happy unless you do something else. People say, oh, being high is so cool and that. None of those rappers smoke weed. If any of those rappers you listen to tell you this bullshit, they probably smoke the most expensive weed in the world that you'll never actually smoke. It's pure, actual, really S-grade weed. You ain't never. It's probably $1,000 an ounce, if not multiple $1,000s an ounce. You ain't never gonna smoke it. You smoke cheap ass rigged weed. And you sit there and get you a little high, but you have to smoke a lot of it. That's how they make money. You got people don't separate that shit from real weed, the reefer? Of course they separate it. Get fucked, bro. Yeah, that's always been the problem. No one wants to see it because you want to be entertained up the ass. Which is why people like me that want to have a knowledge channel, I don't need a bunch of graphs and a bunch of silly ass, stuff to show you that because, you're that much of a child. I'm going to go with colorful graphs and all that stuff then. Yeah, that's why you do that, because you are a child. You have to do it like that. Children like to look at stuff, colorful stuff. It keeps their minds entertained. Yeah, like people back then, all they did was read books and they studied, they researched shit. People nowadays, TV is nothing but a program. These video games are here to program you, but you can still use them as entertainment value, of course. That doesn't mean you can't learn. If I'm at work and that, I focus on my dishes, but dishes are hella easy to do. I already know how to do in the back of my hand. They're very easy to do. I know when I get busy now, certain things I have to react to a little bit more. So I structure myself. So a lot of things I don't do. When people put stuff in the sinks, so to say, like cooks and that, we have a lot of these big, I think they're like 9-inch deep pans or whatever they are, say 6-inch. And I never do them because we have abundance of them. So I leave them to the side. I just leave them there. I don't fuck with them unless I have time to do a couple of them here and there. So I separate what I need to do. So silverware, I always tend to keep silverware up as best I can. So for other people, they throw them in these big old pans, and they let them soak. I'm like, dude, all you have to do is spray them off. As soon as you spray them off, all the food flies off of it. It all goes down the drain. You spray everything off, and I put them in the in the little containers they be put in to throw into the dishwasher. I've never seen, of all the times, the old dishwasher in the morning time, I've never seen them do that. They sit there, they throw them in, they let them soak, and then they pull all of them out when they're ready. You still are separating them already. You might as well just put them in the dishwashing, container so you can be able to wash them. Why are you doubling your fucking work? It's the smartness. I gotta let them soak. I just rinse them off every now and again. I do something, and the other guy started doing that too, because it makes perfect sense. I do a combinational cleaning. So what is after so many, after a wash goes in, if another thing is already stacked up, or I got only a little bit of stuff, then I start to stack it up on that. I scrape it off and I let it sit there. Or sometimes I'll clean out the middle of it. It's all about speed. I clean out the middle of the sink and I throw all the crap away. Because, it's hard to pull out silverware when I notice the sink's filled with a bunch of fucking food and shit. Because, that's what they do. They don't like to knock enough stuff off. They want to be in a hurry now. And people always say, well, you only work, one speed. Yeah, my one speed is faster than everybody else's speed. I only work one way. I can't speed it up because the chances of slipping and falling, chances of me cutting myself goes up. All these variables go up. That's why I don't do it. And the chance of me breaking plates goes up. And I don't need to fucking deal with a bunch of fucking gashes on my fingers and that just to make sure I get washed 10 seconds faster so you don't have to complain about, stupid shit. When you got one man doing a job that two people are supposed to do sometimes, it gets a little harder. That's how you know the difference between people that are positive and negative. The positive people are like, good job, you're doing a good job, let me help you out on that because I don't have any tables right now, or they're eating food. And they'll help me out. They'll bust their tables, they'll separate stuff, they'll do what they have to do. Some of them that are negative in that, they're all in drugs. The ones that are negative, most likely. They'll sit there and complain. We need this, we need that, we need this. I'm just like, if you have time to come back here and tell me that you need something, and you know that I'm busy, grab it yourself. Just like anything else, you have to keep things going. It's like a factory. I have to keep the plates clean so the cook can be able to cook food and put them on those plates, give it to you so you can make money. It all starts with me. If I don't have the dishes done, cook can't get plates. Guess what? You can't serve food. If you can't serve food, guess what? You don't get paid. And then you're supposed to bring back the stuff and continue this thing. Well, once you get the circle that breaks, because motherfuckers be lazy, guess what happens? You're lazy, so you break the circle. So now I gotta go out there and help you out because you want to sit there and talk. I calculated, this is why I love my brain. I calculated 10, almost 15 minutes of them just talking about stupid ass shit. I said in 10 and 15 minutes, you could almost clear out half these fucking dishes and gave them to me. No, you want to sit there and fucking talk about stupid ass shit because you got no brains or whatever it might be. Talk about dumb shit. Just like talk about marriage and that. No one ain't gonna marry your ass. You're single at 40, you're probably not gonna find anyone that's gonna marry you. It's just how it is. Live in fairy tale and all the fuck you want. You're wasting time. Timing is everything and anything, any aspect of life is all about timing. That's why I say 30-second exercises. Do a plank for 30 seconds. Do a plank for a minute. Eventually, when you're sitting there doing planks for five minutes, it gets so fucking easy for you. Guess what? You end up stronger than everybody else around you. It's what kind of blows my mind. I'll be sitting like, dude, are you... What time is it? 12? Okay. I gotta get ready to go. I gotta go get some pre-workout and shit. But yeah, these are the things that I look at, and I get so disturbingly upset about. Because I was walking out there, and I was just sitting there. Anyway, I was walking out there. I was like, okay, you know, I examined all the tables. So I examined all the tables, and I see, you know, what dishes are on tables now. You know, and I'll be sitting there like, okay, you know, I got dishes in the back to do. I just go out there every now and again because I don't know unless someone tells me. I got 3 girls, and they're talking their asses off, and they're just talking about random ass shit. And you know, I calculated how long they've been talking because you know when a conversation starts, it always starts very smoothly, and then you get more emotional with it because you're excited about the conversation. So they were talking about whatever the fuck we're talking about. I think they were talking about marriage or something to do with dudes. And I'm like, you don't need to worry about having a dude right now, girl, because you need to worry about yourself and take care of yourself. And so I was sitting there, and I was thinking to myself, I think I might have said out loud, I was like, you guys have enough time to talk, but you don't have enough time to bust your tables? You guys can bust your tables together and talk about the situation and then come in and give me what I need so I can keep this stuff going. So, well, the manager guy's there. He's a good manager, but, you know, he has his issues. Anyway, he was saying, see, they don't know how hard their job is because they never actually did their job to the fullest because people always cater to them. I'm like, yeah. You know, that's what I say is they make up excuses. And I did, you know, on Sunday night, I told one of the girls, I said, hey, can I have some money for, you know, it was Monday, I can I have some money in that for the tables I busted on Sunday. So with me, you didn't bust any of my tables. Like, yeah, actually I did bust your tables and that. Because I bust everyone's tables when I go out there. Because I'll have no dishes up there because they're not giving me enough dishes. And there's a whole bunch of dishes everywhere. I'm like, okay. So the manager guy calls me, you gotta come out there. And so I'll bust like, you know, I'll do, depending on how big the tops are. So say I bust, you know, 5 or 6 tables. And then I do another, you know, with one bust tub. And I go around and I get another, you know, 5 or 6 tables. And then I start doing my dishes. So I don't make about 2 big bust tubs. Well, I separate everything. I separate the cups on the outside. I separate the plates by how big they are. And I separate the trash. So I know I can just pick everything up, put it all in there, take all the cups out, throw the trash away, I'm done. I don't have to sit there and do all the mechanics. I know I put the silverware into the cups, so I can just throw everything in there. Makes it a lot more easier for me. Then I do it rather quickly. And it's like, it's easier for you guys to separate it. Like, if you want guys to separate the plates and all that from the cups, do that. Don't put everything all into one, and then like, hey, you gotta carry this because it weighs too much. Separate everything. So grab 4 bus tubs, have 2 bus tubs that are filled with dishes and silverware, and another one's filled with cups. So it's easier for me to divide everything. I can get the bus tubs out more better. If the cups are stacked in there right, they don't get the bus tub dirty, it saves me time for cleaning. And no one ever does this shit. And if they do it, they bring it back. When they bring it back by table, they'll grab, 4 or 5 plates, and they'll grab, the 2 or 3 water cups, whatever it is. That makes it easier for me. But when they bring big old bus tubs back, it's hard for me to separate, because I can separate a couple plates super fast and stack them and be done with them, or wash them and be done with them. That's how they're supposed to do it. They're not supposed to use bus tubs unless it's a lot of dishes, like a big party. Little parties, they're supposed to grab their dishes as soon as they leave. They go up there, here's the simulation. Oh, I'll grab these dishes. Oh, these cups here. Oh, let me walk. Hold on, this is the hardest part of their job. Hold on, guys. Open the door. I'm going to make fun of this shit. Oh, here you go, dishwasher. You're the best ever because you actually bust your ass. While I'm sitting there talking about a bunch of random ass shit that never concludes to my job. And when you do bust my tables, I want to make sure I pay you out, right? Because you are busting your ass doing more than what you're supposed to do. Hold on. They never say. Some of them are pretty cool about it, but most of them never say it. I would say no one ever says it, but not like that. Normally it's just like, oh, you did a good job today. But I'm being sarcastic because these people are So here's the angry one. Angry one comes in. Are you gonna bust my tables? I'm like, you see that I'm busy here? And then she'll leave. And then she'll complain about it. And then she'll get mad because she has to bust her own tables. She'll come in, so I busted my tables. I'm like, yeah, good. Yeah, I say, you got legs and arms? You ain't doing nothing? You want... you ain't. I see this person does this all the time. And when I catch her on it, and I told her before, I'm like, I'm not busting any more tables. Because you keep on getting these arguments with me. This is your job. And they say, well, if you're busy, I understand that. But you ain't busy enough. You each get 6 tables. If there's 5 waitresses or whatever it is, you each get a certain amount of tables. It's kind of funny. One of the older ladies there, she's getting on to be almost, I think she's getting close to being 60. I think she is. No, she's already retired now. She busts all of her tables and wipes everything off. She takes the very far corner towards the bathroom. I don't know how many times she'll be in there, throwing down and getting everything going. She does her tables like this. And she'll have big parties too. She'll have parties of like 10. And she does her job really well. And then this person, probably 21 years younger than her, sits there and complains. Oh man, my heart rate's jumping up, and maybe you stop smoking that crack. I got fluid in my lungs. Maybe you stop smoking that crack. And when I say that, it doesn't matter what she says. I don't know if it's true or not, because I really don't know. I think she's lying, but they keep making up excuses for everything. So I say I'm not going to do it anymore. I'll favoritism people that want to give me the respect that I deserve. I'm not a damn mule, and I won't be a damn mule. You're very emotional because your brain's rotting out from the drugs you did. Whatever drugs that might have been. And that's what the problem is. This is the reason why we have problems in our world, that your job is your job. No one can tell you how to do your job if you do your job to the full extent of what you know. So the full extent of what people know is what? What they already know. So if you don't know it, then I understand. It's like some of these girls now, they want to complain about the bathrooms and that. I said, just flush the toilet. That's disgusting. Then flush the toilet then. It's like you have to be able to do things that are hard. Why do people think life's so easy? You can just complain and bitch and fucking moan about not doing your job, and then you have to have someone else to do it. And then all the complaining and bitching and moaning, you could already have that job done. Like, not even joking. Like, that's how it works. You can complain for a minute or two, and that minute or two, you can already have the job done. And then you can feel proud of yourself that you did it. You know what mindset is? It's an idiotic mindset. You officially make yourself dumb because it's easier for you to get your job done when you're dumb. Because you can just bitch them out about it. To me, that is, well, first of all, it's fucking ridiculous. To me, that is. Hey, I got a likey. Thank you for the likey like. But if everyone worked together, that's why I don't like working with unintelligent people. People that just don't do their job. They always want to complain about everything. I'm like, I complain about some stuff, but I'm learning not to complain about some stuff with my job. My job is my job. I do what I do because I do it. Oh man, I gotta blow ass. Ooh. Okay. Yeah, I gotta blow ass. Oh, dear Lord, please help me to release this demon. Oh, no, not now, not on the toilet yet. Hold on. Okay, I'm back. Yeah, I was listening to this one video. It's a video of a woman on TikTok showing how big 12 inches is. And she's like, you girls are crazy. You say guys need to have this and that and this and that. I like, you girls can barely handle, 6 inches, more or less fucking 5 inches. And then I'll talk about, like, how big a foot is in that. It was so fucking priceless. They're like, do you even know how big a foot is? Well, a foot is, yeah, it's fucking huge. Gotta get my shorts on, do my little walk. Man, I gotta stretch out this fucking. Yeah, we'll get it going. Gotta go to something superstore, gotta grab me 2 things. I need creatine, and I need a good pre-workout. And the other pre-workout I had was really good, but man, that was way too much crap. I gotta go back to Buck Up. Buck Up's a little more easier, cheaper pre-workout. Doesn't have all those salts and shit. I don't need all that hydration because I eat enough salt as it is. That was ridiculous. Yeah, salt's really good for you. Salt actually increases thermogenesis in your body. So if you don't have enough salt and you're getting cold, that's probably why you're getting cold, because salt actually helps you regulate heat better. That's why a lot of people, that have like a lot of water problems and that. They go, oh, my water, I have to take water pills and that. You know why you take water pills? It's because they eat too much salt. If you don't have salt in your system, you don't just create shit. Your body doesn't. Your body creates certain things that you digest. So if you eat a lot of salty foods and later on in life you're noticing that you're starting to have problems, it's because you're probably not drinking enough water with that salt to filter it out, or you're not having enough salt in your diet. Fasting is fast. Fasting works really good. Okay, I'm gonna leave my stream on. I might switch perks, go somewhere else. I think I might get him to. Actually, I'm gonna get him to 24 really quick. That wouldn't be too long. That's the next boss fight. And I'm gonna go get my pre-workout on that.
Anyone got a mop and bucket?
Yeah, I really get actual creatine. It actually works out really good. Because you just have, they want you to have at least 5 grams every day, and you want 10 grams every workout.
What the Guy pod is open. Spend your dash and shut up.
I don't need anything else.
Dragging this out. How long will a weakling
Keep it going.
like you survive? Didn't want you to get bored, so I made something special
Okay.
for you.
You just made it really easy for me.
Just get to the pod. You got lucky. You didn't get hurt, but the test isn't over.
Ha.
Red motif thing going on here, huh?
Yeah, I think I'm gonna go with the cheaper pre-workout. I like it a lot. The other one has like huge servings. I mean, fuck, it's like double the servings, but it's just the flavor of it's so strong. It's just holy shit.
To alleviate your suffering. I'm going to try something different. Get ready to die.
I knew it was gonna be like this.
Watch it, more there.
Well, if a sniper's gonna get one of those sentry things, it'd be nice.
You don't have enough money to live. I need to find out how my Zeds are failing to injure you.
Got ammo here.
Wave 20.
Well, I suppose this could help scientifically.
Well, she's right next to me, actually.
My sense potential for serious
Fuck! Yee!
Have a bet about who will kill you.
Yeah, that sounds good. I'm gonna go on before I get hit by a damn storm. I will be right back. Don't forget the likes. If you guys don't come on for a long time, just try to hit that like button. So I gotta get to 300. I gotta keep moving this shit because the algorithm's crap for me. And they're really trying not to push channels that have actual intelligence on. I guess. Okay, I'll be right back. trying one of the chicks. Well, I tried three of them, side chicks. The mango one, the mango, they got more fruits in it. The strawberry, they don't have a lot of blueberries. So what are we gonna have for dinner? Actually, well, it's pretty much lunchtime.
Well, these days say rest off. I actually got most of that pasta salad.
Oh, don't worry about it. Hey guys. Well, do you want to go to Panda Express then?
I did not hear you.
You want to go to Panda Express really quick and get something for lunch?
Well, me and Dad had a pasta salad, but
I mean, we can get a little something. 'Cause you're not coming out to eat till 6 or it's only 2:30. Oh no, I want to go.
I just threw away your box of
Pizza? Oh yeah, it's on top of my thing, so I'm gonna do nothing. Hands like I'm gonna hit the floor. My stream's still up. Shit, I've been going for like 2 hours. Ah! That's funny. I've been going forever. Don't forget to like and subscribe. Oh man. I'm done. I've eaten that. That pre-workout, I mean that. I was thinking about exercising, but digest the food for a little bit. Oh, my nuts. Hey, went up to some of the superstores.
This stuff must be worth a fortune, and it's just lying around.
I saw my little girlfriend up there. Well, she ain't really my girlfriend, but...
You are going to keep your armor like that? Really? Wave 21.
No, not going around too damn much. Fuck. That's pretty cool. Some of the superstores got a little shake department. You can make shakes and that. It's actually really good stuff. You can make protein shakes and that. It is really nice. Basically, it's just an easier way for them to make a little bit of extra money on the side. They have like a little bar stool area. They have a little kitchen in there. It's really nice in there. I love the way they designed it.
That's good.
The trader bot design is not terrible. Horzine is okay with this.
Yeah, I think I'm gonna switch my gun up.
Move it, idiot. Get some gear, ammo, all those things that help you not die.
Anyone need ammo?
Keep the area secure. That means killing his heads to get near.
Mr. Sniper in the house. I need this on the Snapchat. Gotcha. Anyone got a mop and bucket? Wonder what's under the inside.
Should I shoot my rock over this? Shoot up. Fuck off, bitch.
You are so screwed now.
Yeah, I gotta lie, the grenade launcher is probably... This gun is probably one of the better guns for this class. That grenade launcher's too good. But anyway, I was talking to her and that about it. She's a sweetheart. She's actually really intelligent. Well, not like super intelligent like me, but she's just down to earth kind of intelligence. Where she ain't all crabby and stupid and
Work as fast as you can. So,
like, ain't gonna lie, she's really fucking attractive looking. My God, her attraction is very, very high. She's got probably like a 1%er type of body and face structure now. Like, she is just stunning all over.
check out. Any second now.
One thing is, she acts really goofy.
Wave 23. Just get to the pod. You got lucky. The fact you're surviving.
But yeah, I was staying up there and and they have like, I think they have like 10 shakes. They have a summer shake in that they do. They have a monthly shake that they do. And like, it's really cool in that. So they have like 10 shakes. I tried one of them out. It was a pineapple mango one. It was amazing. It was like really good. And there was a blueberry strawberry one. There was like a chocolate blackberry one. or black cherry one. That one was okay. I had a lot of protein in it though. Well, I didn't drink the whole shake. I only did like samples of it because she had leftovers. Like, oh, I might as well give you samples of it so I could try everything out. How much are you for? Sorry, 5 hours ago. What the God, bobbleheads. They give them too much health. Fuck off, bitch. Dude, how do you get in front of me again? The fuck?
That's good. Stop that! I double
Yeah, bobbleheads sucks. I fucking hate bobbleheads.
Spend it all. Money does you no good in the grave. That flesh valve
But yeah, it was pretty cool though.
sort of
I tried out, you know, 3 of the shakes and that. There was a couple that came in there, and they used to come in there a lot and that. And like, they're sitting there, the girl looked, she had like filler lips and shit. You could tell that she had like Botox and or stuff done to her. Because her lips are like perfectly like flailed out and that. I just look at people like that, I'm like, what's the whole point of doing all that? You exercise and look really fucking good. And she does. She's like, oh, she was talking about her hitting 12% body fat. 12% body fat as a woman is way too fucking skinny. That is like, I mean, I can understand if you're like 15%, but 12%? For real? 12%? That is like super fucking like low. I was thinking to myself, I'm like, you're addicted to it, so yeah, body does more for you. You never accept the way you look because you look at everybody else. The thing is, if none of those people that you actually, you know, see now, if you never seen them people, you would never want to be like that. The biggest thing is all about looks. It's about having a healthier lifestyle, having more of a better lifestyle. So, like a guy in good shape or a woman in good shape sees someone's not in good shape. I mean, they're just normal, like they're just average. All of a sudden they're like, hey, you know, I said, you can lose 5% more body fat, you'll have the best shape of your life. Really? Okay. Cool. That's all I have to say. cool, rad, awesome, cool story.
I don't look at it that way. Math is not empirical evidence.
Well, yeah, but when you're talking about these concepts, the way that we understand how things interact, how things high pressure and low pressure, why it goes.
Here's an experiment you can do.
Pressure.
Get a cube, a box that you can suck all the air out of, right? And carry it around with you. But let's say it has a little trap door that can be opened on the side, on the top, on the or the bottom, right? Is there any place, any altitude, any place in this world where you could open that and it wouldn't equalize instantly?
Not that I'm aware of.
So how do we have a high pressure atmosphere next to space, which is no pressure, not even low pressure, no pressure, like insane?
Well,
right?
you know my answer to that.
Gravity, right? So you've seen the train car that they suck the air out of and it collapses upon itself,
yes.
right?
Yeah.
How come?
I think we've all seen those videos now.
If you did it the other way, you agree it would explode, right?
Yes, yeah.
So how do we have spacecrafts made out of aluminum? How's the ISS up there, which has high pressure in a no pressure, not even low pressure, how come it doesn't explode? Because the vacuum chamber we have here on Earth has walls 10 feet thick out of steel and concrete.
David, the hard part is because then you have to start quantifying, okay, how much pressure is in here, how much pressure is out here, so you start getting numbers. And then you have to start using mathematical relationships to describe why something would or would not
Forget
happen.
that. Show me reality.
So that's what I'm saying, Dave. I'm saying
Google Earth showed you, using math, how the stars should rotate. Reality shows you something else. That pilot didn't use any numbers. He filmed reality. But Google Earth used mathematical equations and numbers and everything, and it worked perfectly for a globe. But reality. So show me in reality. Don't show me in Narnia math, right? Show me in reality. Take a box of vacuum, find a place where you can open up in any orientation that little window, and it won't equalize. And the answer is you can't. Nowhere. Not in Death Valley, not at the top of Mount Everest. Nowhere. It'll equalize instantly. That shows you that we are not on a globe. We're not on a globe. I don't believe space is a vacuum.
But
okay.
So if I was to show you what pressure was in a spacecraft, for example, and how maybe it wouldn't overcome the structural integrity of the outside of it.
Let me interrupt. All right, go on YouTube and search vacuum chamber. Okay, they explode. Anything you put in there explodes. When they put a soda in there, it explodes. Okay, when you open up a soda can, it equalizes instantly. Right? Get a vacuum chamber and put something in it and suck the air out. It's going to explode. Okay, it's going to explode. Right? But the space station, no problem. Their seals work perfectly. Everything works years and years and years. They run around in gorilla suits up there. They got a mini meteorite, put a little hole in it, and they fixed it with duct tape and gum. Okay? They're mocking us, Joel, and you're buying into all of it. Okay? Listen, you are a super book smart guy. You're a nice guy. You're super book smart, but your book is Narnia. You're literally living in Narnia.
I'm not sure how I could respond to that.
Because, Narnia is kind of a nice place. It's kind of fun there, I heard.
Yeah, I would agree. But
I wouldn't know, though.
Yeah, of course not.
Well, what do you make of the, I mean, I mean, I know it's one thing to say that, well, we just disagree with your beliefs, right? I mean, that's one thing. But what about when you have the people, I won't even call them the so-called elite, but like some of the people who have come out with some of these theories, like Kepler, saying that we need to, or sorry, was it Kepler or Hubble, that said that we must avoid the unique position in the universe at all costs. Such a position is unwelcomed and would only be accepted as a last result, as a last-ditch effort to explain a phenomenon. In other words, what he's saying is we will make up anything, literally anything, including magic bendy light, in order to save a model that will mean that we can explain away some certain observations. Observations, of course, that we're not moving, that we're at the center. And believe it or not, observations that we are, in fact, not curving. Again, those would be radar. We have radar propagation over 10,000 miles, and it apparently operates in the manual off a line of sight, meaning you point and shoot where you think the target would be. There's no calculation for bouncing it off of the ionosphere, and we even have radio waves that go over the 100 megahertz broadband, which means it goes through the ionosphere. We have clocked those at over 2,500 miles. These observations alone, by themselves, destroy the curvature claimed by the globe. And so we don't have good evidence of its curving. We have evidence that it's flat. We have as you even admitted, no evidence for the celestial model that doesn't beg the question. So there's no...
When did I admit that? Oh, that doesn't beg the question.
Right, reified. That's why you don't know how to answer when we accuse you of living in Narnia, right?
Yeah, right. But I granted it to you when you just said that, because you said we have observations of this stuff happening.
Right.
So you were doing the same thing, but I gave you that because, you can't always avoid that. It's a very particular fallacy that's one of the hardest to avoid, besides like the fallacy or something like that. But, So you said the same. I need to say that you made the same claim. We have these observations as evidence for the flat Earth, and that's kind of almost exactly what I was saying.
But the difference would be between, and I could give it to you that that's a reification, right? Because just because it shoots as if it's flat doesn't necessarily mean that it's flat, right? It just can hint at that, right? So I would give you that. Yeah. But the difference between our observations would be, again, that we can recreate ours here on the ground. The things that prove out your observations demonstrably are probes, NASA, again, everything that relies on the accused or reifies the issue.
Well, what about astrophotographers, like amateur astrophotographers?
They take pictures of the sky. What about them?
Well, I mean, because they use a lot of these theories and methods, and they use these star trackers, and they use...
So what they use... So the only thing that you need to know in order to be an astrophotographer really is the cycles, obviously, of the celestial bodies. But then also you just need to know how much they move in a day, which is about 1 degree per hour. So, I mean, as long as you know that, I mean, you don't have to do advanced calculations, this assumption, right, that you have to know the layout of the cosmos as NASA and the mainstream presents it in order to take pictures and things up there. It's actually ridiculous when you look into it. It's not even claimed that that's the case.
Joel, what happens when you go back and you decide to look at that mountain, that 700-mile mountain thing, and you can't come up with an explanation that works on the globe? What would you do? What are you going to do then?
Well, that's hard because it's very hard for me to just not accept a no explanation. So I mean, I feel like I would keep trying. And
here's the thing: that observation, although it's not easy for anybody, but anybody could go there and do it themselves, right? It's not. We don't have to go to the
You can do everything I showed you yourself too.
No, you can't. You're looking at things that you can't tell. Right, if I didn't move that train forward, you can do all sorts of measurements, and you can say that light was 250,000 miles away when it was only 1/4 mile away. You can say it's spherical, but when it wasn't spherical, you can say anything. That's not. This is something we're viewing a terrestrial object that we know where it is, we know how high it is, we can go measure it from another terrestrial place. We're not looking into Narnia. You're looking at Narnia.
Well, with things like Jupiter's moons, for example, like you could watch.
Can I call them the light that we call Jupiter the little lights that are near it.
Yes, I know,
Okay.
Dave, but we're trying to be charitable to each other's positions
Okay.
here. So,
Yeah.
you can Jupiter rotates once every 90 minutes, which is insane to me. But you could watch it rotate. I mean,
Yeah.
it's such a big planet, but it's rotating so quickly, and you could watch its moons in a telescope rotating around the planet through
I'm
the
with
night.
you. I'm with you.
Yeah.
I'm with you.
Oh, yeah,
So
things like
let me ask you
that.
a question. Jupiter, what's Jupiter made out of?
Yes.
Spectroscopy should tell you. It's made out of helium and hydrogen.
Not necessarily,
mostly.
because it's not emitting light. It's a failing
So,
star.
so what if?
basically.
But it's not. It's like 98% hydrogen and helium. I heard.
Yeah, well,
Is that right?
speak. I don't know.
Spectroscopy should tell us. It's right here. We're not looking at it. It's not trillions of light years away, or millions of miles and millions of light years. It's right here. So the spectroscope. I'm trying to say both words at the same time. It should be able to tell us what Jupiter is. It should be able to tell us what Jupiter is. Okay. So mainstream science says that it's both. Correct me if I'm wrong, Skylar. It's helium and hydrogen. Is that right? Am I right on that?
That sounds right. Yeah.
Okay. So helium and hydrogen kind of defy gravity here on Earth. They also tell us that Jupiter has more gravity than all of the other planets combined. How much helium and hydrogen does it take to create more gravity than all of the planets combined?
A lot. Quite a bit.
And so more of something that's lighter than air. It doesn't make any sense. And then if you were on Jupiter,
it's lighter
bright-
than
let me ask
oxygen
you a
and
question.
nitrogen. But yeah.
How NASA says that from Jupiter the sun would be very small. It would be like a quarter of the size. It'd be like a large star.
Sure. Yeah.
Okay, so you have to believe if you're on Jupiter and it's a gassy surface, I wouldn't call that very reflective. I'd call it kind of light absorbing surface. And the sun is really small and it's far away. You have to believe that that faraway sun is lighting up the gases, reflecting off of them back to us. And yesterday, not it was yesterday, but the last time I saw Jupiter in the sky, it's the brightest thing in the sky next to the moon. Okay,
Yeah.
so how is that light getting intensified, reflecting off of that non-reflective surface, traveling millions of miles back to my eye, not getting any dimmer, getting brighter? How is that possible? How come when I look at a rock on the ground at noon that's much closer to the sun and much more reflective than a gassy ball, how come it's not shining bright in my eyes? Because I'm right next to it. Okay? It's not as bright. When you look at Jupiter in the sky, it's as bright as the sun. It's just smaller. It's a light. It's as bright as the sun. It's just smaller. Right? But I should be able to look at a rock on the ground and it should be brighter than Jupiter. But it's not. It's not.
Make God,
if you had a,
Make God Great Again says Smurfers just don't know how time traveling eyesight works. Obviously, Dave, we probably should just pack it up, call it a day.
Okay.
I don't understand. Like, it's not getting bright.
Let me ask you a question.
It's
Is
just
this-
reflecting
is this-
the light off of.
Is the light reflecting off of this blinding you right now?
No, it's not
It
the
should.
sun reflecting off.
It should. Now, if I
You're outside.
Hold on. If I was outside and the sun was over there, it would still just look like this. And this is actually kind of pretty fucking bright here. Okay.
I'm craving pizza.
The sun reflecting off of this.
Craving pizza? I thought you guys mean that thing.
Oh, yeah, but I haven't had pizza in a while. I know you had pizza, but do you want to eat pizza with us? No, we're gonna get a medium. We're getting Chinos.
Well, but she's thick as fuck. She ain't gonna be eat that medium all up anyway. Their pizza's this fucking.
No, it's not.
Their pizza's this fucking thick.
It's not that thick.
Yeah, it
No,
is.
it's not. It's not thin. It's not
You know
that
how they
thick.
make it? They put all the meat on the bottom. They put cheese on top of the meat. This shit's fucking like this.
Well, just put less cheese.
Oh no, I'm just saying it's just a really big pizza. That's what I'm saying.
Well,
Yeah, I don't mind. You guys grab that, whatever. You know, I'll probably eat it later today because I'm gonna exercise here in a little bit.
okay, well, we'll just buy a large then.
You know, you get a large, just get a medium. Well, I mean, you ain't gonna be able to eat all that no matter what you do.
Oh, we'll get a medium then.
If you guys want to get a large, just get. You guys want to get a large, you just eat it for the next couple of days. It's fine.
We'll just get the meaty.
Yeah.
Yeah, well, all of it. It's like a.
Yeah, I know what you're saying. These people are
But
hilarious.
Jupiter, it's a light, right? But you have to believe that a distant sun, a smaller sun, is reflecting off of a non-reflective surface, traveling millions of miles to my eye through my atmosphere, and I can see it as bright as the sun. I'm sorry, you're not thinking if you're believing that's what that is. The only reason that you're defending it is because it has to be that way, because that's the way it is.
Well, I just don't think that position that you're describing is accurate. Because
All right, explain to me how we see Jupiter as bright as the sun. It's bright. It's a bright light in the sky. It's bright light in the sky.
It's not nearly as bright as the sun.
Okay, but it's brighter than any star. It's bright. It's literally a light in the sky. How is it lit up? Explain to me how it's lit up.
Because it's reflecting what's showing behind your screen there.
It's reflecting the sun.
Yeah.
Okay, so how come when I look at a rock, I'm standing next to a boulder here on Earth, that's a smooth boulder, and it's kind of reflective. How come it's not as bright as like Jupiter? It's bright. It's literally like a small piece of the sun. It's like a small piece of the sun.
You know how big Jupiter is.
You're not explaining how
Well,
that
I'm saying
that light's
because-
intensifying.
Well, no, it's not intensifying. What I'm saying is you have a massive planet. A planet.
It doesn't matter. It doesn't matter because the sun
well,
is.
Dave,
Hold on. Let me just finish this point. They say the sun's 400 times bigger than the moon and 400 times farther. Therefore, it's the same size. So if I look at a rock that's this big and I'm 5 feet from it, okay, well, Jupiter is so far away that it looks smaller than that. It doesn't matter. I'm right next to this. The sun is shining on it. It should be blinding me, but it's not. And the sun is closer to this, right? It should be blinding me. That argument alone completely destroys the light in the sky being a gassy ball planet that doesn't tell us.
What are you seeing?
As Skylar said before, I don't know. I think it's something to do with creation. I think we're all part of this living system, and those lights in the sky are part of this system. That's why astrology is what the real elite use, and astronomy is for the masses to keep them believing in space.
Well, I certainly don't believe in astrology, but
well, that's of course because you believe in astronomy, which is complete and total hypothetical BS. With being nice.
yeah, but like Venus, for example, is much brighter than Jupiter. I'm sure you've seen Venus in the morning.
I have. I saw Venus last night. It was right next to Mars, and it was also very bright. Now, Venus, you can kind of argue, is closer to the sun, and it's reflecting, but Jupiter makes no sense. Jupiter makes no sense.
Well, it kind of because you can't see like Neptune or Uranus with your naked eye.
Because they're not what they say, right? They're not what they say.
But then, what are they? I guess if I were to accept, okay, they're not planets, then what am I supposed to?
That's not.
I guess.
Listen, I don't know. I'm not responsible for coming up with the answer when you don't know what something is. I don't have to come up with a replacement model. But if you look at Jupiter, hold on a second. This is what I want to show you. This is from this is from NASA, right? Why isn't it so bright? How did they get it? Did they turn the aperture down?
We need to know the exact source for that. I don't know.
Actually, I'm sorry, the storm one. That's a pond with ducks.
Nice.
That's not what I was doing.
That's good. Yeah.
Come on, I said you have to have a joke, okay?
That's funny.
All right.
It's even funny because
Here's Jupiter that NASA has. I'm trying to find the one. Oh yeah. So this is the space probe that took a picture of Jupiter. How did they get? What did they have, a solar filter on there? Because Jupiter's
what did you say took that picture?
This is from NASA. From some Voyager or whatever took this 2014 and 2016.
So it was a passing by.
Yeah, but again, you have to believe that this is real, and none of the clouds changed over 2 years. Every cloud is exactly the same.
Are we
Okay,
just going
and-
to breeze over how those look literally identical to the little the
That's what we're
miniature
talking
Jupiter?
about. Oh, yeah, the one I just showed.
Yeah, it's identical, and
See, what happens is the guy believes in bullshit, and the flat earthers are telling him that you believe in bullshit, and he doesn't get it because he believes in bullshit. He's look at his face, he's sort of like dumbfounded. Because you've been falsified, like you believe in astrology instead of believing in, astronomy. Well, he said astrology is meant for elites because they actually know what's going on. I have a freaking astronomic stuff is made for the peasants so they don't figure out what's going on. For astronomy and astrology. Yeah, astrology is actually real. Zodiacs make sense. Astronomy doesn't make sense. Yeah, it's because it's made science fiction for a reason. No one wants you to know what the creator made for us. They want to keep it all for themselves. It's not saying they're bad people. They just want to keep the creator stuff for themselves, which is not what the creator wants us to have. Everyone should have the same capacities, but they put it underneath lock and seal. So we could sit there and fight upon each other. Oh, this is what this is what that is, and it's like religion's the same thing. Religion was created to separate us. It wasn't created to put us together. It was there to separate us. Even the Quran book or the Bible book has been around a lot longer, and it makes more sense than the Quran, the Muslim faith and stuff like that. This isn't what the problem is, people. It's like if you don't know where you live at, you don't know what you're doing in your life, seek that guidance. Pray to your creator. Seek guidance. Money's not everything. Money's just a course of action of survival. It's a manipulated tool to keep your brain busy so you don't notice these things. That's all it is. That's all it's ever been. And I'm gonna get some more water. And the less that we know, the more we get put into that matrix. Like I know a lot of people that they have a lot of money in that, or they're very high influence people in that. Not like they know them, but seen them, and they don't know anything. They really don't know anything. They just know how to make money, and they know how to do business. And that's about it. I'm back. But yeah, this stuff's getting seriously. It's getting serious. I ain't gonna lie, this probiotic stuff help out a lot. Though the funny thing is, I was talking to, there was a new girl up there at something superstores. Anyway, I was talking to her about myself and that. I said, it's like, yeah, I research emotional, psychological things. You know, I talk about zodiacs and spiritual stuff and that. That's just the tip of the thing that I know. And she's like, did you go to school for that? I immediately say that, like, what do I have to go to school for that for? I'm like, so you want to say that reading a book makes you smart? Or actually having anecdotal evidence of that issue or that actual, like, answer to a problem, answer to a question? Like, so for people, as they read books, they read it from someone else. What if that person's wrong? Yeah, you never know because you're going to believe that they're right. They've done tests, and okay, I've done my own tests with emotional stuff. I've been angry before, and when I felt massive anger, I control the anger for just a brief moment. And you figure out what anger is. Anger is like a massively feel-good hormone. It's not really a hormone, it's more or less like a feeling. You get a lot of it, you get adrenaline from it, you feel good when you get angry. And most times it's because of a mistake or a problem that you have. Same thing with sadness. Why are we sad? Because you don't know the outcome of what's going on. So it's like if someone dies, does anyone know the outcome of death? Well, you could think of things, okay, reincarnation, okay. It's just the way life is. But some people can never go through that cycle. They're thinking death, oh, I miss them so much. They're not truly dead. Ghosts and spirits are real. Like, they're real. They've been proven to be real. They're based on an electrical phenomena, because, you know, we are electrical beings. Our souls are very heavy electrical entities, and we are still in the realm. You know, we stay in our realm, we stay in the earthly realm for a little bit, then eventually pass on to another realm on our earthly planes. And for people to completely understand that, is that everything's connected with electrical magnetics. You ever like see that people give off a lot of energy when they're mad? You give off a lot of different vibrations. Your electrical self projects enormous amount of electrical feed. And if a ghost is around you or a spirit could not be able to form because it needs to feed off of things, then it does. And you start having phenomena happen, like things falling or things being hide. I had a ghost hide my phone multiple times. Multiple times. Something was hiding my phone. All of a sudden, like, it wasn't there. And all of a sudden, it'd be like, I look around for an hour, and then all of a sudden, it'd appear out of fucking nowhere. It'd be like, in a really stupid spot. That is exactly what it is. Man, I really wish shooters would call me to get my damn job back, but I doubt it. Don't know, people. But yeah, that shit's crazy though. Yeah, it's extremely crazy when you think about it over and over again. We watch all these ghost hunter shows and that. Yeah, there is a lot of fake stuff, but sometimes the stuff is actually honestly real. And people are always going to say it's going to be fake this, fake that, fake this. It's like nothing's really... There's a lot of fake bullshit out there. Of course. Yeah, 80%. But yeah, that's just how it is, and I don't think people really understand that. Like, there's a lot of truth out there, but you have to be willing to look at it. Oh man. Ate a lot of rice and now you're for things I just. Come on, go outside, baby guys. You ready? Yeah, I'm gonna try to look at some stars tonight. Got some really good binoculars. I mean, I probably won't be able to see much, but it'll be really awesome to look at stars and see if I can be able to sit there and see stuff. And no, I don't have any hot girlfriend and neighbors to spy on. And all my neighbors, like wives and that, are all old now, so I can't really say that they're really like super attractive looking, or as attractive looking. I know my one neighbor's used to be friends with for a while, now we're younger not. His mom was fucking stupid attractive looking. She has some super nice boobs. She knew it too. She used to show them off all the damn time. Not like that, but like she showed a lot of cleavage and that.
Not that it will matter. You'll still die. You think killing a script is some big achievement? Please, you're pathetic.
Yeah, I remember like it was yesterday. One day she was we were sitting there eating pizza at a table, Matt. She came in, she had a tight-ass shirt on, like a little black bra on. And she bent over with her panties on and that. It was fucking priceless. And like everyone was staring at her ass. Dude, it was so priceless. And that was like, fuck, that was probably like 14 or 15, I guess. And she just walked in there. You know, she was getting something. She's fucking hunched over and that, and you can see her little fucking asshole and all that shit. And I'm like, are you fucking for real? I'm like, you know, a bunch of teenage boys here. And you're sitting there. You're a super massively attractive looking woman. And you come in with barely anything on. And you're just like, I don't care. She definitely knew that she was hot. When you have that much confidence that you know that you're attractive looking, that is astounding, because she was. probably one of the hottest, probably one of the hotter girls I've seen in a long time. She's very attractive. Come on, boo boo bots. Go on, turd monkeys. Yeah, like, that was just funny though. I always thought it was hilarious that she did that. No, yeah, that shit was just crazy.
These stuff like this, Jupiter's not the only one. They have one of the moon too. I've heard that from.
Well, Skylar, they use this picture to make that model. Come on, it's not the other way around. That's crazy.
I do think.
You're right.
I do think. I don't know. I'd have to look at exactly. I'd have to see what they said about those images specifically to see.
I'll tell you what they said. They found out that Jupiter has a magnetic core because they filmed the Northern Lights.
Yeah.
That's crazy. Come on. Now let me ask you a question. Did I put this in there, or did NASA put this in here? Do you know? Can you prove either way?
No, I don't know.
Okay, but
that's what
when
I'm
you
saying.
find,
I have to look at it myself.
So if I put it in there, did I do a good job?
Sure.
Really? That's good. That's believable. So if NASA put it in there, then it has to be real. Do you see the bias that you have?
Not. See how I'm not just accepting it though. Like I'd have to see.
I appreciate that.
You can see both of you can go and look at Jupiter, and it looks just like that. Is what I'm saying.
It looks just like this. This is the new picture of Jupiter that NASA just gave us. All right? You believe these are paintings.
It actually doesn't look like what you're talking about unless you use some digital imaging and rendering with it, right? You're not going to get Jupiter.
No, that's not true. You can see it.
You can see some blurry. You can see some blurry bands and a little. I'll give you. You can see a little spot and some blurry bands, but nothing to the detail of what NASA's claiming.
Well, with a legitimate telescope, you can with a big Dobsonian 12-inch telescope. It's just purely optics. It just has two mirrors, right? Three mirrors.
Joel.
And it can look like that. You can see. Joel. It's not just blurry bands. You can see the detail and the red dot and everything.
So, Joel, if you do the research and see that the 2014, 2016 photos are both claimed to be from NASA and all of the clouds are the same, what will you do? What's your excuse? What will you say?
Well, I'd have to see what they say about it.
Let's say they say these are two separate pictures. The second one showed that there's Northern Lights. Okay. What will you do? Because you now have evidence that they're lying because all the clouds are the same. When they show us this, the clouds don't say the same. This is just over a couple of days, okay? Right? The clouds are moving, right? But they showed us 2 years apart. The clouds are the same. So I'm not saying that, you have to do your own research. When you find out that that is both official from NASA, can you completely say NASA's a complete and total fraud and throw out everything they've ever given you? Or are you going to make it?
Well, I wouldn't go to that extreme because that would be a slippery slope fallacy, which I'm sure you're aware of, Skylar.
But it's
you can't throw the baby out with the bathwater.
But it's the burden of positive claims and letting things pass through the lens of empirical of what can be empirically verified.
Fuck 'em up!
Again, we keep having to on the low side rely on the story from people who came admittedly from Project Paperclip. If you don't know anything about that, you should definitely look into it. It wasn't just America, though. That's actually what people don't understand. It was America, China, Russia. It was all the big countries took Nazi scientists and then employed them in their own scientific programs, not just the space program, right? So, for us to just blindly agree that okay, what they're giving us is factual when they do show us like horrible footage like this, like you can make stuff like that just super easy today, and all you need is a little bit of computer magic to do that. If you take in even 1 year of stagecraft, then a lot of magic from NASA just kind of fell away.
Yeah, I think Again, well, I take things on a case by case basis. So I'll look into the mountain things. I look into the inverse square law thing. I'll look into the high pressure versus low pressure thing, and then I'll look into the 2014 20. So did you make those images or?
No, those are from straight on the NASA's
Okay, so you
website.
didn't make those. Okay. So yeah, I'll look at those and see what they say about them, and then I'll also reference those against other amateur images that we have. But yeah, no, Skylar, I did need to make sure that you understood that we can see Jupiter with a significant amount of detail.
So let me point that out. Yes, you can. And Jupiter is actually a train with 8 different lights on it. Okay. Okay? I mean, you don't know what Jupiter is. You can see it. It doesn't mean it's millions of miles away, that it's a giant gas ball made of helium that has more gravity than all of the other fictional planets, okay? You're believing a story and using it to reify your belief.
I mean, yeah, I guess in general, but doesn't mean the story is necessarily false, I guess. So like, we all accept a narrative perspective of reality ontologically.
Okay,
so
quick question
you have
about,
to start somewhere.
Quick question about Jupiter for clarification. The method that you use to get the clear picture of that, is that similar to the method that you use to also get the clear pictures of Neptune, where you have to allow so much photons to come in to build out the picture, and so it doesn't
Like
give it
long
to you.
exposure.
Yeah, exactly. It doesn't give it to you instantaneously, right?
No, I'm saying with a big enough telescope, if you're getting a picture, it's different. But if you're using a telescope for direct observation with your own eyeballs, or even directly into a camera, you can see a significant amount of detail, like Dave you said.
So I mean,
and
I guess
then you can also see its moons around it.
I'll even give you the moons. I've actually seen amateur photographers with cameras take pictures of the moon. So I'm not saying that you can't see that. Again, I was talking the insane detail that you're seeing between the different colors and the clouds. Like that only comes from NASA. And any time that I've ever seen anything like that from any amateur was because they had the long exposure. They had it digitally rendering through a computer. And in my mind, there's no way to verify that the program, the software, is not actually just building the image of what it is expecting to see.
I mean, I'm sure you could do it yourself and try it. I have an astrophotographer friend who took it up in New Mexico, and he's
like
done
build
it himself.
Build the software from scratch and everything. Huh?
Well, I don't think the software's biased. It only takes in what you puts out what you put in. I guess it's not going to do something so like off, where it just flips from one image to another. You have to meticulously yourself hand.
Well, I was just saying, if I was at the top and I wanted people to believe in this thing, I could potentially put out a program that just gives people the proper, correct images of what they're supposed to see. You wouldn't expect it to be off because it's programmed to be right. But I'm not a coder. I wouldn't,
Hey Dave, I think is one of those things that that's put in there. I think one of those. So those are actual objects. I think that it's using, right? At least that software. It's using actual images of things, is it not?
It's using it's all CGI, all of it. It's using CGI images as CGI images. Okay.
Oh, I see.
You believe that they're all real.
Oh, I can't really tell through the.
I
was just
once took the deep star field that they did a time lapse, of a piece of the sky the size of a grain of rice, and they saw like 1 million galaxies. You know what I'm talking about, right?
10,000 galaxies. Yeah.
Yeah, 10,000 galaxies. I took that and I put it into my film editor, and I zoomed all the way in on the smallest area I could, and then I did the effect where it just starts panning out slowly, and I made like a 30-second video of it just panning across, and the stars are going, and then I posted it, so it looked like it was from NASA. And I got into a week-long argument with Globers saying that, no, it's real, and telling me how they did it and everything. And then finally, when I revealed it, they all went silent on me. So
yeah, it's kind of funny because on Facebook, I'll call out. There's a lot of space. Well, this probably sounds funny coming from me, but there's a lot of legitimately fake space stuff that comes out, and I'm always the first guy to comment that, and everyone's like, oh my gosh, it's so beautiful. I'm like, wow. It's like, no, this isn't real for X, Y, and Z reasons. And
you're halfway there. It's a huge niche that's actually muddying the waters quite a bit.
Yeah, it's really unfortunate for, I think, both of us, honestly.
Well, we're not the ones
it's-
with the. Honestly, it's not so much of a problem for us because we don't have the positive claim, right? We're not claiming that the Earth is a curving, spinning, wobbling, tilting space ball. Which, I mean, we didn't even get into, since you brought up rotation was brought up briefly. I mean, we didn't even get into all the different wobbles that the Earth has been experiencing over the last several years that they've predicted or is somehow required for the model to work, including
Yeah, we could get into that next time.
yeah, for sure.
So, I want to bring up one thing. You know, they have Earth-based telescopes here that take these deep field images, and when they took the deep field image, they said that the telescope is mounted on a cement block that's 10 feet thick, a huge cement block, and it's perfectly leveled or whatever. And the operator during this 10-hour exposure has to walk around in socks because the vibration of his shoes could ruin the entire exposure. Right? You've seen the documentaries on that, yes?
I didn't watch the documentary.
Yeah. So they talk about that, but then you have to say, well, while he's worrying about the vibration of his feet, the Earth is spinning at 1,000 miles an hour. It's orbiting at 6,000 miles an hour. It's chasing the sun at 500,000 miles an hour, and the entire galaxy is moving sideways at millions of miles per hour. And how does the tiny vibration from his foot make a difference? And then you look at the Hubble telescope does these long images too. It's doing everything that the Earth is doing. It's traveling 17,000 miles an hour around the Earth while the Earth is going around the sun. So it's moving in 5 different directions at once, and it's able to hold itself steady on a grain of rice-sized piece of the sky to take a deep field image for hours and hours. I'm sorry, that's a religion. That's a ridiculous story.
Well, what's the explanation that you heard for that?
The explanation is it's fake. There is no Hubble telescope.
What is the explanation?
They won't address it. They don't address it.
Oh, no one's addressed that with you?
No one will address it. I know exactly what they're saying. I know exactly what they're saying.
Yeah, that's what I'm
perfectly, or it's perfectly orbiting around the Earth. It's perfectly matching the spin of the Earth, the orbit of the Earth, the speeding up and slowing down of the Earth. I mean, it's insane.
So I guess the question is, why would I don't want to get into this now. We can do that next time because that's another whole topic. We're just like Earth's rotation, I guess. We could get into that next time.
Well, you can, but no one's ever measured it. Okay, no one's ever.
No, I'm saying an explanation of why you wouldn't feel it and like how that all would work, like the mechanics of that.
Well, that's the thing. Like, you can explain away the observations. Literally all.
Yeah, but what's the counter explanation? I guess what's wrong with the explanation?
Well, here's the thing. It's explaining why we don't experience any movement. I don't need to explain the problem with that. It's explaining away an observation. The observation is that we aren't moving. But your side wants to invoke that we in fact are. So in order for that, you have to beg the question and create a mechanism for that. We have no need to do that because we're not asserting that we're moving.
Yes, but you are asserting that the explanation doesn't make sense. And what I'm asking is, what about the explanation doesn't make sense? But that's what I would like to get into probably in a future podcast, because it has been 2 hours.
All right, Joel, any final comments?
No, I mean, I think it was fun. We touched a lot on a bunch of different
Give fucks, bro.
a lot more than I think I expected.
What are you doing?
But I think it's fine. I think it was a fluid conversation. We were never bickering or kind of.
If you had to pick your one best proof the Earth is a globe, what can you pick one or?
I would say the celestial movements. Yeah.
The movements of the lights in the sky that
Well, you could call them lights in the sky, but
if you call them stars that trillion miles away,
you guys did acknowledge that it did make sense on the globe if the globe is real.
No, we acknowledge that some of the movements could make sense, but we wouldn't be able to observe them because we could all be dead, right? And I'm going to think about it because it's amazing that light gets dimmer and dimmer and dimmer and dimmer until it just gets to that dim point, and then it just goes forever. It's amazing.
Why would you expect otherwise, I guess? Like what?
Because light spreads out, and it keeps spreading out until it's so dim that you can't see it, and that happens very quickly.
Well, yeah, until your eyes can't see it, but it's still there. Like,
Well, we can still. So how are we seeing stars that are hundreds of trillions of miles away?
So, like in a galaxy or something?
No, like stars in our solar system. Well, 100 billion miles away, whatever. We can see other galaxies that are 200, as you said, 200 light years, right?
Andromeda is 2 million light years away. 2.4.
2 million light years. How many miles is that, dude?
Well, so I guess what's stopping those photons from that galaxy coming to Earth?
Yeah, nothing. They spread out. They spread out. They spread out. They spread out. Like this intensity of light here, 10 feet away, it has to spread out and fill this much area, and then 20 feet away, it has to spread out and fill a bigger area, and it becomes less and less and less.
Right, but it doesn't become non-existent, I guess. It doesn't go...
It just goes forever, and you can see things trillions of light years away.
So what's wrong with that? Like, what, you know?
It doesn't make no sense, that's why. How big can you blow up a balloon before the plastic's gone? Now, you blow it up forever, because the balloon's going to get thinner and thinner and thinner, but in your world, after it gets to 10 feet wide, it can go to 1,000 feet wide and 1,000 miles wide. Right? At 1,000 miles wide, you couldn't find the surface of the balloon because it would be gone. Just like light, just like sound.
What were you going to say, Skyler? If the photons are spreading apart, then at what point are the photons so spread apart that there's not a photon that will go out?
Is this some sort of prank? You're not this good.
It's not it's because of the nature of light that's hard to answer, because you got to think of like just a rays of spherical light coming.
So is light photons? Is light photons?
Yeah.
If there were no photons hitting us, there'd be no light, right? Okay, so you have a surface of a star, and it has X number of photons on it. And as that expands, those photons that are all side by side, they're all touching each other, they get more and more spread out, more and more spread out, exponentially spread out, okay? At what point will a photon completely miss Earth?
I'm not sure. I don't know.
It's not far at all. Do the math. You'll see that it's not far at all.
What I was going to say is I think it would have to be a pretty far distance, and I think the math would reflect that.
Like what, 100,000 miles?
The problem, Dave, and I say this with charity and respect, but even if I did do the math, it's almost a waste of time. And you know why? Because once I present the math to you, it's like there's nothing I can,
Math is not empirical evidence. Math is not empirical evidence. Let's try to keep our feet on the ground.
It's not charitable to say do the math when you won't.
Well, I'm saying if you do the math, it won't work out because the photons are become too far apart. Okay,
well, that's what you said about the inverse square law, and it did work out.
Well, no, it worked out in math. All right, you're right. It doesn't work. Let's just stay here on Earth. Explain the observation away of the mountaintops. There's no curvature calculator. Even the worst Globee Pro calculator puts the tops of those mountains 20 miles below the curve.
No, I'll look into it. I'll see.
Okay.
Whoever this other Joel guy was, you seem to want him to check
Oh my God! There was two Joels, and it was crazy. It was crazy.
It was funny. But,
All right.
All right. Yeah.
Thanks, Ben.
Yeah, absolutely. It was fun. Nice to meet you, Skyler.
Yeah, Joel, thanks for coming on. It was very nice to meet you. Just to let you know, if you ever want to dip your feet in this again, I do an open panel usually tonight at 10 p.m., but we did this instead, so I was definitely happy to change it up a bit, give the audience a little something different, and I know
What's your YouTube? You got YouTube?
Yep, Troubling Tribune.
Oh, it's just Troubling. Okay, cool. All right.
Yep, so
well, awesome. Yeah, I hopefully it was sort of productive, swapping perspectives and whatnot, and giving our sides, and that's what we were here to do. So,
all right.
Hope you guys enjoyed it.
If the Globies, anti-flat earthers, could be as nice as you, well, life would be amazing. Life is amazing.
Certainly,
it'd be more amazing.
That's Dave. That's why I told you I even started doing this in the first place, seeing how you were treated.
The problem is that there's anti-flat earthers that will literally make just bad, bogus arguments that now genuine people digging through this stuff have to then hear through. And unfortunately, it can be kind of easy to fall into the bad information. So,
that's on both sides, I think, for sure.
Absolutely. So on any side, you're going to have disinformation, as it will. So always important to use your own research first.
Yeah, I agree. I'm a strong proponent of that. So, alrighty guys, you have a blessed night. I actually like your shirt, Dave. That's actually kind of cool.
Thanks.
It's the back of it.
No, it's,
You can find that on my new T-shirt shop on theflutterpodcast.com. It's a shop.
oh, you made that shirt. Nice.
Yeah. I have a whole bunch of new shirts and new printer. They're much higher quality printing and they're awesome. So check out the shop, everybody. It's also on your app with the shopping cart button.
Nice. Alrighty guys.
Everybody else check in your app, and if you don't have it yet, you're definitely going to want to go to Blackbird, Zodiac, on at by Water Bay, and use your referral code review so they know that you sent you.
Nice.
Also glad that we were all able to avoid the admin and fallacies. That's always nice in any kind of disagreement.
We almost poisoned the well a few times, but I think we did a pretty good job.
Yes, I agree. So anybody who's wanting to comment or whatever, like I ask that you just please, be respectful.
And the chat was actually pretty. Was okay. They could be quite passionate. They become passionate, and I used to do it too. So sometimes I do too.
Alrighty, guys. You have a blessed night.
Alright, if you want to check out the outro, we're going to play an epic outro on our way out. So for you guys just joining us, you want to stay for just a moment, that'd be absolutely awesome. Dave, do you have anything else that you want to do? Add on before we close the show?
No, that's it. I'm good. Thanks.
Awesome. Alright, you guys have a wonderful night. I will see you on the other side. Peace.
Peace out.
Alrighty, guys. What an awesome conversation that we just got to have there. Let's move it on over back to the next page. Perfect. Awesome, and Joel does indeed love space, but we definitely like having him on. Great conversations. Hopefully we can have him on again and continue on. Maybe go for a trilogy of sorts, if you will. But while we go ahead and wrap it up, I do want to shout out just a couple people over in the Rockfin side as well as the YouTube for doing a lot of work. Keeping it real busy. We got 25 legends over there supporting on Rockfin. There is a link in the description if you guys would like to subscribe if you have an account already, or if you don't, what better time to go and check it out. Right, there's other content creators out there doing some great work. There is Sharonism, Karen E, Mark Sargent, myself, Mellow Dome, and many more. So if you want to know, you really got to go. But shout out to a couple people, Willie, Danny, Lord Byron, much love, as well as Fishhead Montana, and Lord Byron, Roger Meadows, right, lots of back and forth on the guys with the whole thing. John Osborne, awesome. If I missed anybody, you are still appreciated. All right, let's head on over to the YouTube. All right, many thanks. This was a great stream. Thank you, Betty Boy. It was a lot of fun doing this. We got Jesse Palmer, True Meat, Cinchman, Lord Racer, Dirt, or yeah, Dither. It's hard to pronounce Dither, so I just naturally want to say Dirt because of all the anti-flat earthers out there. I do apologize. We also have JK, Jeff Palmer, Silver Soul, Unchained Mind, Dr. Ball. How is it that you are not a member? That's crazy. We have Justin Johnson just giving out tons of memberships. Absolute legend, putting the entire tribe on his back. We got Chillin', Joshua, Sarles, Thrash, List, Smith, Middle Wheel. By the way, we also have a members-only stream coming tomorrow night at 10 p.m. We're doing an Ask Me Anything, and I will be joined by my lovely wife, Ms. Tribune. So it'll be a nice chance to get to know us a little bit better. Only have the members chat and members only viewing to avoid the trolls. But we do appreciate everybody being a part of that. So if you want to join up, now would be a great time. Also get your absolutely sick emojis. We got the Mind Mert emoji and the True Earth Cosmology with many, many more. As you know, one way.
Yeah. No, I love when I see a whole bunch of flat earthers get together. They talk about shit, they figure out new shit, it's just astounding.
Mankind
You'll
tries
throw my results if you die too fast. Buy armor. You can't even pick that up.
Yeah. Damn, dude, I'm trying to keep myself awake. My food's digesting so much. Oh. That shit's crazy though. Got my pre-workout. Big ass thing of creatine. Yeah, I'd rather make my own pre-workout. Well, technically I'm not making my own, but I have my own creatine in it because I hate that most pre-workouts have no creatine in it, and creatine is a huge source of helping you regenerate muscle, not. Oh, does give more strength. I don't know what I want to do. Oh, let's try to watch that maiden thing really quick. I think I'm going to do that.
Your dinner's ready whenever it suits you. May I ask what you've been doing out here?
The moon is just so beautiful. It inspired me to do some thinking.
I don't come in here often.
Yeah, you stay up for a little bit. Let me go in the bag, get ready to go to work. These 3 days went by super quick. They always
There's
do.
no reason to anymore.
Been paid tomorrow.
My grandfather came
I don't know what's happening next week if I'm going to be working all the hours.
here late at night to practice. Apparently, his dance partner at the time was your mother. Don't you find it fascinating? Think about that. Long ago, my grandfather and your mother danced in this very room. It was fate that brought us here.
Yes, I agree. It certainly could be an act of fate.
Perhaps we should really try it. I mean, obviously I can't touch you, but we can coordinate so it feels like we're dancing.
Sorry,
Oh, I see. I thought it would be fun.
unless you ask like a proper gentleman and not the common.
Good old coach.
Of course. May I please have this dance?
I'd be lying, sir.
What the fuck's with his range of this weapon? It gotta be so fucking close.
Close. I don't like to touch you.
I'm used to it. It's just, I haven't had many opportunities to dance before.
Neither have I.
It's more difficult than I imagined. But, like,
This area remains mostly secure. As long as helping you somehow. As this is
Yeah, I'd rather have the scythe back. Things don't have much range. I'm missing half my fucking heads.
They would be impressed. Area remains secure.
You just happened to see me? Ding.
Why do you insist on getting in the middle of a family dispute? Do something useful and die running away.
I'm a pussy.
I can't see them.
This is how success really works.
Gotcha.
Oh, it's perfect. Yeah, I'm such a dork.
Danke.
Boing.
Some things never change.
What time is that anyway? Oh, it's only 5:15. Okay. I think I'm gonna get off right now and get back on a little bit later before I go to bed. I have the power! Okay, everyone, give thanks to your creator and have a blessed day.